Hello? It is time. Okay. So... I seriously need a solution now for the rotation of the body. There's also one thing I've noticed that I probably shouldn't do anything about it. But it's the fact that the rest positions are... So let's say I have it faced slightly to the right. The rest positions are going to rotate to the right. So if it looks that way long enough, it's eventually going to reach that point and then say, all right, here's my legs. And then it's going to reposition. There's an idea there where the look orientation is not necessarily matched to the body orientation, or like the leg orientation. I probably shouldn't do that though. I should probably just leave it where it tries to keep its feet in line with the body as best as possible. Yeah, okay. So, sorry. Before I even start, I want to make sure that I should really have like an actual solution for rotation. One that I can stick to, and then I'm not going in there with a half idea and then changing that idea. Okay. Whoa, that was really laggy. Okay, so So body orientation. So there is I'm just going to write it out. There is a desired pitch and roll determined by the target positions of each leg. I know that. I also know there is a limit to pitch. Well, it's more like this. The body can pitch up, down, by some limited angle relative to the desired pitch. Also say the body always tries to correct or roll. I think that for possibly what I have to do for yaw is what would be smart is to take that vector. If it's do that math function on the vector where I determine if I want to do yaw, which is just that the cardioid shape. And if I say yes, then I should probably flatten that vector to my... I should flatten a vector. Okay. I take my current yaw, I flatten it to my desired plane. I'll call it this. Well, this is what we call the desired body plane. So I take my current forward, I flatten it to my desired body plane, and then I take my desired forward and I flatten that to my desired plane, and now I get that gives me a yaw rotation. And then for pitch, I think essentially what I have to do is I take my forward vector and I flatten it to my vertical plane, so like my horizontal slice. I orient them both to be the same direction. I flatten it so that I can just get a perfect difference in rotation between my up and my desired up. And then I can limit that. I also take my desired up and I clamp that, right? Somehow I need to clamp that. So to calculate the yaw, take the current forward and the goal forward, flatten to the desired body plane, take the signed angle between them on the normal of the desired plane. And this is the normal that I rotate on. So then I take this normal and I project it with my... It's not really my orientation. What do I project it with? I mean, I guess my desired plane... Because what I have to do is I have... Okay, so the normal between them... The angle between them on the normal... on the normal axis of the desired plane. Pull it up. Of the desired body plane. So this gives me a yaw rotation, and then I have to apply that yaw rotation oriented to the desired plane as well. I feel like it kind of becomes an issue when the current forward is far from the desired plane, or maybe not projected well onto it. Honestly, a general issue I'm having is that the angular velocity is in global coordinate space and not in the body's local space. So if I orient the body like this, and then I add a Y rotation, it's going to turn like this, right? It's going to do a roll basically. But if it's flat on the plane, then a Y rotation will actually do yaw. So does this mean when I apply this yaw, does that have to be... Okay, for now, all I know is that this is... Okay, no, I don't know that. I don't know that. It needs to be... This is probably the part that I struggle with. There's like a starting point where I calculate the angle, and there's an ending point where I apply the angle. In both of the, it has to be calculated for what it's going to be applied to. Essentially the completed code on Discord. I'm sure you did. There's some emojis in here. Why are those there? Yeah, I'm not making an array of dictionaries. Thanks. I appreciate your best effort on that. Okay. I think the question I need to answer is, where is my source of truth? What is my actual orientation? Is it the desired body plane, or is it the actual orientation? So here's the thing. I won't be doing yaw unless I know that I'm not basically pointing vertically. If I'm not pointing vertically, then I'm fine. Okay, so, alright. No. I think about it this way. So the Y, that's it. So the Y, the yaw that I've calculated, it needs to be applied on this normal. That's exactly what this is. So how can I apply it on this normal? I could think of it as being a vector pointing in that direction with that value, or with that length, right? And then I need to orient that vector I mean, yeah, that orientation is basically pitch and roll. But I have the pitch and roll. Is there... Oops. Let's go here. So plane is essentially just a vector. It also has a distance from the origin. Well, I guess I have a desired... My desired forward. So the roll is essentially which way the right vector is pointing, and I want that to just be the same as to match the left to the right, or whatever direction it would be. Yeah, I guess left to right of the legs. But actually, if we're pointing the other way, then it's probably right to left of the legs. So I have that vector, I have a forward vector, and then I have... oh man. And those two already give me an up vector. So I've actually got a basis already. And that basis I would just be able to use for all rotations. If I just produce a basis and I calculate all of my angles from that basis only, I use that basis to apply rotations. Okay, so desired pitch and roll. Okay. So here's what I do. I calculate the desired forward using the vector pointing from the back legs to the front legs. Calculate a desired right using the vector. I mean, since we're pointing the other way around, I mean, I guess it is the right vector is going to be left to right. That is, you know, correct. And then from these, cross to obtain the desired up vector, pointing away from the ground. From these vectors, obtain a basis on which all rotations be calculated and applied. Now, I guess the only problem is what happens when I detach from the ground. Let's just assume we're always well grounded. I'm just going to say that. Not being on the ground is definitely a different state where we're probably not going to be doing those rotations. And we can't even do them anyway because we don't have any attachment to the ground. So how would we apply a torque to ourselves? That just doesn't make any sense. So our legs are always on the ground when doing these rotations, calculations, and when doing rotation at all. Okay. Compare the target direction with the up. With a plane, determine if your rotation is allowed. So, if so, in this case, it's actually as simple as just saying, take my take the angle between my current forward, my target forward, on that basis vector. I don't need to do any flattening, I think. Current forward and target direction on the desired let me say this. Preferred. On the preferred up axis. This will be the yaw. Angular target. And then I should just be able to honestly compare all of these, right? Well, the pitch is a bit different, and then I think... But no, because if I'm applying this to, like, my desired stuff, then it should work out. It should work out. Anything weird that I see... Okay, so what's a possibility is that as I rotate, some legs that are on an elevated surface now drop down further. So I'm not on a flat plane, but I'm like on a stepped surface. And those drop down, and now my preferred forward is level with the ground, perfectly level. It wasn't on a plane. It wasn't on an incline. Now it's perfectly level. So what happens is suddenly my yaw, my roll will be dramatically wrong. So that will have to be cut. That will have to be corrected. And then, you know, any weird stuff like that, I think that's acceptable. I think it's stepping down a step and then maybe doing a bit of a wiggle should be okay. So then I have compare the current up with no, I say take the signed angle between the current up and the preferred up on, so technically this would be roll, but also my preferred forward is using my legs, which is also technically aligned to, I mean the preferred right is, no, angle between the current right and the preferred right. So this is essentially saying my right is actually always aligned with the leg right. At least it should be. As long as all my legs are in a straight line, like if you look top down from the top, every pair of legs is only lateral to each other. They're not forward or back at all. If that happens, then it's always going to try to rotate. Take the signed angle between the current right and the preferred right on the I kind of need to know two things, because I do want it to pitch up, but I guess for now I won't have it pitch up. Honestly, I could actually just take away pitch up entirely. I could just say orient your forward to where I want you to point, but then don't do any pitch. Could I do that? You know what? Let's say that. For now, I don't really need it to be able to look up or down slightly. So yeah, I'm just gonna say, take the signed angle between the current right and the preferred right. Yeah, I just point in the direction roughly on the yaw, and then I'm always trying to make sure my right and my roll and my pitch are good. The current right and preferred right on the what axis? I guess on the preferred forward axis. This will be the roll angular target. And then it's the same thing for pitch. Take the angle between the current forward and the preferred forward on the preferred right axis. This would be the pitch angular target. Obtain a vector with all of these components and rotate it by the preferred basis. Then move the angular velocity towards this vector. Is that what I should do? Let's just start with this. Let me just get this, and then I can make it do things like... Okay, no. Let me get it all right. Yeah, one of the requirements is that all legs do have to be on the ground to get this. Well, I guess not really on the ground. I just need that they could be on the ground. Use the next. Use the collision point. Let me say this. If the leg is grounded, use its current... use its current target position. If it is not grounded, use the current collision point of the step target. If there is no collision, yeah, probably what I say is if there's no collision, use the current forward. I'm more thinking of if I am missing the back right leg, but all other three legs are on the ground, but the back right leg is not on the ground and there's no floor there, so it also can't collide. What do I say? Maybe what I say is if there's no collision, use the rest position if the other leg is colliding. If there's no collision on just one of the legs in a pair, use the rest location of that leg. If both legs in a pair are missing, use only the other pair. If, and this would essentially mean I have, I'll say use the other pair if all, I'll say if both legs of a step use the other pair if both legs are grounded. Or have a collision target. Otherwise, use the current forward as the preferred forward. So this is also dodging the case where one set of legs is incomplete and the other set of legs is also incomplete, but together they could both be used. Or I could even cross it. I could even say if I have two good contact points on the front left and the back right, then I could use that. But that's kind of, I think, not desired. Yeah. Also, you know, there's kind of like a, I don't know if this is like some sort of meta thing. I guess it is. I'm making a robotic crawler in a game, but also I want to make it in a way that makes that an actual software developer would write it. So there's some fail safes, but not like unlimited fail safes. You know, that's a good reason for me to say that looks weird, but this is also an edge case. I ignore it. I should really keep that in mind. Maybe I could even keep that in mind and drop a lot of this. If the leg is grounded, use its current target position. If it is not grounded, use the current collision point of the step target. If there is no collision on one... What the hell was this sentence? If there's no collision on just one of the legs in a set, use the rest location of that leg. I might even just drop this one. Well, maybe this makes sense. I feel like there are cases where like one of the legs could go off. Honestly, I could even say if one of the legs go off, if I'm missing one out of the 4 legs that I need, I compute... I use the good set as the forward, and the one set that's on the ground as the right, and that's my plan. If I'm missing 2 legs... Yeah, you know what, let me... Can I? I kind of wish I could just open this and draw in here, but I can't. Let's go here. So here's my idea for this. Actually, I want to go back to those colors. These colors back. Okay, so I have... Alright, go to white. So I have legs like this, and then I have any number of middle legs which are just not relevant to these calculations of orientation. Okay. So here's the possible sets. I have all 4 green legs. These are legs that are grounded. And I'll say I could also have... Alright, let's say this. This makes more sense. I could have any leg that is not... a single leg that's not on the ground, and I should be good with that. This is kind of... These are just dots. These are just dots. But these are all good sets. I can definitely 100% work with each one of these sets. So then there's the case where I'm missing 2 legs. And I'm using green for grounded, red for I can't even get any data out of it. There's no collision, it's not on the ground, whatever. But green is 100% definitely grounded, it's currently in contact with the ground. So what happens if I'm missing... I mean, I'll just draw them all out. I'm missing 2 legs now. And these are the sets of... This is like really terribly organized, honestly. Make some lines. I should do straight lines instead of just freehanding it. Okay. Yeah, now this one is red. Is it all of them? There's 6. I mean, that seems right. The back with every other one. The back right with every other one. Top right with every other one. Top left with every other one. Yeah, okay. It's every combination. So out of these, which ones can I work with? What can I... How could I mark this? This one's bad, for sure. Let's do that. This one's bad. This one's bad. I mean, they're actually all bad. If there's absolutely no collision... Yeah, they're... Okay, so they're all bad. Alright. I wouldn't be able to do anything with that. So now here's where I say... In this pair, this might be an example of... Or this one, I mean... If I really think about it, there's a lot of information here. I can get this vector, and from that one I can grab the forward component. And that's my forward. And I can grab the right component, and that's my right. Technically on these two, there's enough information there that I could produce those orientations. With those vectors. What was my thinking? If there's no collision on just one of the legs in a set, use the rest location of that leg. So this is the idea. Wow. Can I press the keys that I want to press? Okay. This is the case where I could use the rest position of this leg and just say, all right, there's my forward. Or I could even just say, here's my forward, here's my right. But probably getting the rest position of this one might be better for orientation. So if I have all four or I'm missing one leg, I'm probably fine. Yeah, I think this is just the case where if I'm missing more than a leg, then I say, do your best. Maybe. Yeah, let me say, if there's only one leg missing, use its rest position. If there are more than one missing, use the current forward as the preferred forward. Same process as preferred forward above. If I'm missing one leg, I can work with that. If I'm missing two, then that's it. From these, cross to obtain a preferred up vector. So to cross that, I would take my forward and my... Yeah, I guess I would take the forward and the right, and that gives me the up. I gotta take the dog out. I'll be back. I'm back. I mean, technically, if I'm missing more than that, then I need to use all of these. One second. Wait. Yeah. Okay. I'll be right back. I gotta comb a little bit. Okay, I'm back. Manage coast to obtain a preferred up vector pointing away from the ground. So what happens if I'm missing more than 2? Let me see this. Yeah. If no legs are in contact with the ground, do not attempt, or yeah, do not do any rotation calculation. I'll say like probably just apply damping. What's like... Is there like a type of friction that's just like rotational friction? Like I'm not... Like if I have a sphere and it's in some fluid and the sphere is just rotating, like it's only experiencing... It's not like pushing through it and being stopped because it's like running head on into water. It's stopping because it's all the points of rotation are in friction with the water. Though it's not actually pushing anything out of the way. I'll do that. For later, apply damping as if by friction with the air. Okay, calculate a preferred forward and a preferred right. Use cross to obtain a preferred up. Vectors obtain a basis on which all rotation will be calculated and applied. The target direction with the plane. Okay. Compare the target direction with the plane. What are these? There's a diagram I saw once about this. I think it was just on like axis of rotation or something. And it gave me it's called the transverse plane. With the transverse plane XZ. I'll say y plus. The plane defined by the y-axis, essentially. Towards yaw rotation is allowed, if so take the signed angle between the current forward and target direction on the preferred up axis, so the yaw angular target. And then let's do the pitch angular target. And I guess I can say, in this case, I actually can do this for later. I can take current forward and the preferred forward on the preferred right axis. This would be the pitch angular target. For later, take the signed angle between the target forward and the target forward. Oh, hang on. Is this a case where I can do like a dot with my up vector? Okay, so it's sort of... Wait, can't I? Hang on, I could, can't I? If I take the dot between... Or not even this, but like... No, I mean, it would be a dot. For later, take the signed angle. So not really this, but take the dot of the target direction and the preferred up to obtain a... I mean, this is a signed angle. To obtain a signed angle. Clamp this to a min and max pitch angle. Multiply by the dot of the current yaw. Or I guess multiply it by the, what is it? Multiply by pi minus yaw over pi. This will be the pitch angular target. Am I all there? Am I all there? I might be all there. Okay. If no legs are in contact with the ground, do not do any rotation calculation. For later, apply damping as by friction with the air. Calculate a preferred forward using the legs. If I'm only missing one, use its rest position. If I'm missing more than one, give up. Just the current forward and the current right as the preferred vectors. Calculate a preferred right. The same thing. Cross to obtain a preferred up. From these, obtain a basis. Now, compare the target direction with the transverse plane to determine if yaw rotation is allowed. That's the cardioid thing. I'll just write this. Cardioid formula. If so, take the signed angle between the current forward and the target direction on the preferred up axis. Signed angle between current forward and target direction. The yaw angular target. Signed angle between the current right and the preferred right on the preferred forward axis. This would be the roll. Angular target. Take the signed angle between the current forward and the preferred forward on the preferred right axis. Current forward and preferred forward on the preferred right axis. So the pitch angular target. For later, take the dot of the target direction and the preferred up to obtain a signed angle. Clamp this to a min and max pitch, multiply by pi minus yaw over pi, the pitch angular target. Obtain a vector with all these components and rotate it by the preferred basis, then move the angular velocity towards this vector. How do I account for missing legs? The acceleration, it's like an acceleration multiplier. For every leg that's not grounded, I reduce what I can do. For acceleration, at least. And then I think it's the case where if any leg is uncomfortable and not moving, I am not allowed to do yaw rotation. Okay, so what I'll say here is if any legs are, let me say, if all legs are if any legs are not comfortable and not moving, which means they're on the ground, they are not taking a step, stop rotating the yaw. So if all legs are either moving or comfortable, then compare the target direction with the transverse plane to determine if yaw rotation is allowed. If all legs are either moving or comfortable, I'll say this. That is, no legs are both uncomfortable and not moving. Okay. I think that's all that I need. Okay. I'll do this. Rotate by the preferred basis. Move the angular velocity towards the towards the multiplied vector. Towards the rotated vector. Using an acceleration multiplied by the grounded leg factor. Then I also have like the minimum thing, but maybe, yeah, I'd like to also get that if possible. Alright. I've got to get this figured out. I've got to get this figured out. Right now. Alright. Whoa, I just hit a bunch of keys. Okay. Alrighty, so I've got a... I've got an angle here. Blue is where I'm at right now. Whatever this angle is. And I will say green is my target angle, wherever this is. Right? And I have a specific angular velocity that will arrive me at that point in a single step. So here's what I really want to do. I want to say move by at least essentially, here's the thing. If I need to rotate... Let me make this easier. Alright. So I need to rotate a positive... I'll say this is positive. That's probably like 30 degrees, I think. I mean, these look like roughly 30-degree steps. So I need to rotate a positive 30 degrees to get here. So here's what I say. Because it's a positive rotation, I want to move my angular velocity towards positive pi. So that every second I'm rotating half a circle. I'm rotating 180 degrees every second. I'm moving towards that angular velocity. However, there's a certain point where the difference is so small that I need to start slowing down or stopping. Right? I have to begin stopping. So what that means is I compute the difference between these two angles. So this is the 30 degrees. And I say, all right, I have 30 degrees to go. I cannot move any faster than 30 degrees per second. Let's say that. Okay. Let me use all the terms, okay? So I want to move towards a pi radian per second. However, I know that I'm actually operating in steps, which are smaller fractions of a second, so I could compute, given my current angular velocity, do I pass that angle in a step? My current angular velocity multiply by a step. I guess take the difference, right? So if my difference is 30 degrees, I mean, yeah, that's my difference, right? I say 30 degrees. Paint layer. That's a terrible 3. Just okay. Oh, wow. What is wrong with my hand? That's just not how I would draw a 3. That's just not, I swear. It's so bad. That's better. All right. 30 degrees is my maximum, is the angle between these two right now. So then what I can do is I can say, all right, well, what's my current angular velocity? My current angular velocity is, when multiplied by a step, gives me the number of radians I will travel on this step, this very next step that I'm about to apply. If that's greater than 30, then I say, all right, I need to move to... I need to say, all right, well, I need to move my angular velocity to that value. So whatever that value is. So I take angular velocity multiplied by a step. Actually, I guess I can take 30 degrees, multiply it by a step, and that's my maximum. 30 degrees multiplied by a step. Not necessarily. Well, that would be my value. I guess that's my max, I guess. So if I'm rotating a pi radians per second, let's say pi radians per step, and I guess this is what would this be? Pi over 6. Yeah, and I have pi over 6 radians to go. That multiplied by the step. Well, I guess not really. It would actually be that divided by the step. Yeah, okay. So I take this angle, divide by t. Let me draw a fancy t. That is like my upper limit. If I end up with a value greater than that, then I can't do it. I have to... Okay, so I would use a min between my current angular velocity and d over t. Delta, these look like these are just the same. I just drew the same thing. Let me draw a better A. Better. All right, so I use the smaller value between my current angular acceleration and d over t, however far I would need to go in a single step to cover that distance. This is my move target. So A is actually my target angular velocity, which will just be like positive pi, negative pi, whatever. And then d over t is that step what I could cover in a single step. So if it's 30 degrees per second, then that's my limit. I can't go more than that. So A would put me like over here, right? A would put me here. However, 30 divided by step would put me there. Or 30 times step would put me there. But because I do that division there makes it so that this is the correct value after it's multiplied later. As the step increases, the minimum value goes down. As the distance decreases, that minimum value goes down. Okay. All right, I think I've got it all. I think I've got everything that I need at this point. I'm confident. I'm confident. I've got everything I need. And I think I'll just start writing from the top. Hey, Danon. I think I've got it finally. Today's the last day for sure. Oh, this is, hang on, let me actually write it out then. Get a vector, all these components are rotated by, okay, so before I rotate it, obtain a vector with obtain a vector pitch, yaw, roll. Yeah, divide this vector by the delta time. this gives a maximum angular rate. This gives a maximum angular rate to achieve... No, yeah. This gives a maximum angular rate to achieve the goal rotations in a single step. I probably will actually multiply this by a value smaller than 1. Multiply it by a value between 0 and 1. Wait. So here was my thinking behind doing this, is that say I have to pitch up 10 degrees and rotate 10 degrees. After I do that, my thinking is that what should happen after I do that is I actually now have a new roll correction to make. So it's never going to be... I mean, I guess there actually is a way to perfectly calculate that, isn't there? Wait, if I have a pitch, yaw, and roll, is this where I should use a quaternion to get like a very precise change? Because I'm looking at all these individually. I mean, alright, I think what I can actually do is I could take my current basis, compare it to my preferred basis, which is all of these, and then get a quaternion rotation to make that happen. And technically that would be like the most accurate. Because at least in extreme cases, applying these over time creates a lot of errors, I think. Maybe this is a good case for that. Because I know at least in the case of doing the pitch and the yaw at the same time, I pitch up and I yaw. I pitch up and I yaw, right? Like, I start turning like this. I start rolling really, really hard when you pitch and yaw at the same time. Because the initial calculation is going to say, yeah, pitch up and yaw. But then at that point, I will have acquired some roll that I don't want to have, which means if I did like a proper quaternion rotation, it would tell me, yeah, if you want to go from here to here, you need to do this, you need to do pitch, yaw, and some roll backwards to fix that part. That's probably what I really should do. I straight up take my current basis as a quaternion, and then I find out, I compute the quaternion to rotate, the quaternion of my what's the main thing I get? The main thing I get is I get a yaw that I want to apply, and I get essentially, given my current orientation, I know that my target has some fixing to apply to it. So I could take my target. If I want to do yaw, then I say, all right, I'm going to do yaw. So I take my target and I flatten that and I get that forward. And then I compute, and then I do crossings to get an orientation that I would like to be to reach that point. Because I get the plane, so I know the plane. I flattened it to the plane. I know the up. I can cross those to get the right. I would really do the forward cross with the down to get a right that actually looks like it, and then oh no, this is why it doesn't quite work, because if I were to do that, the shortest angle might be to flip all the way around. But I guess if it's always in the plane, then the shortest thing to do is to always rotate either 180 degrees forward or 180 degrees around. So I guess that works. Maybe I should look at this again. He creates a quaternion using the difference. Then he takes his current orientation he rotates it by that difference, and then he rotates it back. So it's essentially go here, turn, go back. I mean, that's what it looks like to me. Invert. Invert. I mean, maybe that's exactly what I should do, because that's what I've got, really. I have my current orientation. Maybe that's actually the correction for it. Rotating it somehow back by the inverse. Somehow rotating it back by the inverse is a fix to prevent you from doing that or something. Or maybe that's just, I don't know, maybe that's just all you have to do. Let me go see. Because now I'm actually curious about that. Okay, where's the quaternions? JOML. Okay. It could only be from here. Oh, what is that? Okay. Whoops. Main. He's using F. What? Oh. I understand. You can really do that? That's just crazy. Does inverse just return everything being -1? Or invert? Because inverse and invert could be different. Or, I mean, you can use those words to mean two different things. It's just making the value negative, or like actually doing some kind of math to compute some opposing orientation. I should have done a Control F to find this. Okay. Okay, there's math. All right. So invert is what he is calling, right? He's definitely writing invert. Invert. And that's what it looks like. It does 1 over fuse multiply add x times x plus y times y plus z times z plus w times w. That's just crazy. Okay. Sure. Sure. What do you do for invert? What is your invert? They have inverse. Inverse. Not the same thing. The quaternion must be normalized. Is normalized. I mean, that does look like a length to me. I guess that's what it's doing. Why is length square here, but not length? X times x plus y times y plus z times z plus w times w. X times x plus... This is the weird part. Multiply add. Does that mean for some reason I always thought the multiply add was applying the add before the multiply? But does that actually matter if you add two numbers before you multiply? It does matter. So I guess it does the multiply first and then it adds. So x times x plus y times z plus w times w. So this is just taking the negative of the xyz, normalizing it, and then the w stays the same. Is that the case here? Okay, so inverse and invert are identical, but it must be normalized, which it will be normalized. So, all right, you know what? I'll try that. I just take the difference that I want to make, I throw that into a quaternion, I do that, and then I pull the angles back out, and these, I guess, give me corrected angles, right? Though I'm just not sure what invert does. That's like, I really don't know how that math works, but you know what? Maybe I just leave it. And I just accept that I don't know exactly how that's working, but that it's working and it's doing good things. All right, attain a vector. Attain a vector, pitch, yaw, roll. Obtain a quaternion pitch yaw roll. What do you... Yeah, okay. Am I spelling that right? Yeah. Whoa, 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 whoa. Obtain a quaternion of... These are all applied relative to my preferred. They're actually computed from my current right, current forward. Current forward, current right, current forward. Yeah, okay. Obtain a quaternion of the current basis. I don't know what that means. Obtain a conjugated quaternion by this operation. It is orientation multiply difference multiply orientation invert. Obtain Euler angles from the resulting quaternion. This will be the angular I think what it's really doing is it's taking this, go here, and then like flip it around or something. I don't know. So I think about just pointing forward, my difference is to 180, so I say 180, and then I transform it. I don't know, really the orders that take that difference, I transform it by my current orientation. And then I take my inverse orientation, I transform it. Like I don't understand how that doesn't make sense. This will be the angular difference vector. This will be the angular difference vector. This will be the angular difference vector. Obtain a... Then I'll say this. Divide the angular difference vector by the delta time. And this will be the maximum rotation rate allowed for the current step. And I'll say obtain a target angular vector by multiplying a unit vector with the sine, or by multiplying the sine vector of the angular difference vector. And taking the min between that vector and the divide the angular difference vector by the delta time. Take the absolute value. This will be the maximum rotation rate allowed for the current step. You can target angular vector by multiplying the sine vector of the angular difference vector with the min between the maximum rate of the current step and the maximum rotation rate overall parameter. Multiplying the sine vector of the angular difference vector with the min, so the maximum rate of the current step, and the maximum rotation rate parameter. This will be the limited target angular vector. Rotate the limited target angular vector by the preferred basis. Of course, the rotated limited vector using acceleration multiplied by the ground leg factor. I'll say the ground leg factor is the number of grounded legs over total leg count. Good? Is that it? Maybe. All right. I think I just try it. This seems like everything is there. Alright. First step, if no legs are in contact with the ground, do not do any rotation calculation. Can do yaw is true. And I say if the leg is not, I guess I say if can do yaw and what do I say? No legs are both not comfortable and not moving. Okay. And yeah, at least one leg has to be grounded for me to do anything. So I say if grounded legs equals 0, to do damp rotation as if by bare friction. Must have at least one leg grounded to perform rotation. And I guess I can go and calculate this. Grounded leg factor. Okay. Give myself a big divider here so I know where I'm really at. Okay. So if I'm missing one of my 4 legs that I need, then I can use its rest position. If I'm missing more than one, then I give up on that calculation. I just say my preferred forward and my preferred right. Okay, so what I'm doing right here is I'm getting my preferred forward and a preferred right. Okay. Let me grab these. I really cannot. Leg count -2. Leg count -1. So here's what I could say. I guess I could say if my grounded legs is less than 3, then I know for a fact I definitely don't have these. But it's also not exactly grounded. It's either... If it is grounded, it's where it's currently sitting. If it's not grounded, it's where the step target is. And if I have none of those, then I say... Or I guess it's really... If it is not moving, I check if it's grounded. No. If it's not grounded, I check if it's moving. If it is moving, I use the let me do this. Let me call this the main legs. And it's going to be these. Oh man, hang on. Yeah, I want to do an array, and I guess this is also probably where in the future this should be an optimization point. This is just to like crush down on the calculation I'm doing because I need to check, I need to essentially store the position that I'm going to use for each one of these legs. But I want to do that in like a single for loop. And if at any point in there I say, I'm going to use the rest position of this one, and then I say, all right, on the next leg, am I already using a rest position? If I am, and I need to use a rest position, then I give up and I say, okay, our preferred forward and our preferred right are these values, and we stop. I'll say in for that one. Okay. I'll call these ground points. For I in range 4. Min likes I. Is it false? Okay. So now just say if the leg is grounded, then ground points I will be equal to leg target position. Otherwise, leg is moving. Ground points I will be equal to leg. And when I'm moving, here's what I'm doing. my step target. I'm using the step target. Step target. Right, because I'm always moving towards step target. That is it. This is literally eventually where my target position, becomes. So, otherwise, if I'm already doing all of these, if I'm not using a rest point, actually, I guess I can just say if I am using a rest point, then I have to say use current orientation. So preferred forward will be state transform basis Z. And just looking at it from above. Yeah, that's right. Yeah. And then I break. Otherwise, using rest point is true. And ground points I will be equal to this legs target global rest. Right. Yep. Okay, and then down here at the bottom, I just check if preferred forward, if it is not finite. I'll say this up here. Note, initialize. Let me just do a Boolean instead. I'll just do that. Using rest point var then I'll say this. Using current direction is true. Okay. Then I say if not. Actually, I'll say this. Skip. Or no. I want to say using ground points is true, and I'll say using ground points is now false. And I say if using ground points. Okay. And I technically have a plane here, so how can I do this? They should always form a good plane. What's my goal out of this? Basically just obtaining a basis. For basis, if using ground points. Otherwise, was it looking at with an up vector? No, I'll just say I take a forward, cross with a right, which will actually be pointing right. No, I'm doing the wrong way. Forward, cross with a right, gets me the up. So, yeah. Preferred basis will be okay. Yeah. So I'm going to compute preferred forward. It will be end minus start. So yeah, it'll be ground points 0 minus ground points 2 3. Add those together, normalize them all. I guess I don't really have to normalize it here. Yeah, it doesn't change the result, so I can just add them together like that. Bird right. Very similar. Calculation. So it'll be end at the right, start at the left. So it should look like that. I mean, I guess I can actually just do this. Preferred up. And now I have preferred basis. Hey, pawn. How's the project going? I think, well, I am not happy about how long it's taking me to get this thing to rotate. This is just a complex problem, but I did work it all out. At least in English. I'll only know at the end if all my reasoning was correct. But hopefully, this is just it. Hopefully this is just it. Okay, now I've got... The process that I'm going about this is probably what I really should do for a hard problem like this, is that I should write out everything, make sure I have the whole recipe, and then follow it. And if it doesn't work, I don't know what to do. Honestly, I don't know. I'll figure out when I get there. But I'm sticking to this. I'm not going to do any deviations, no testing in between. Okay. This vector is a basis on which all rotations. If all legs are either moving, so this was So can do yaw is checked up here. So I have this already. Compare the target direction with the transverse plane to determine if yaw rotation is allowed. So if can do yaw, so I should just calculate it here. Whoa, 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 whoa. Whoa. Alright, so this is the cardioid thing, which is this. So I'm just going to copy that. If can do yaw, this is saying can do yaw false. Okay, so here's the difference now. So x dot, I'm comparing, this is my preferred up, I think. Preferred up dot with the target direction. Yeah, dot with the target direction. So preferred up dot with that gets me essentially, and then 1 minus gets me essentially how in the lateral plane it is. Yeah, okay, so this one I kind of don't like because it's just kind of coming out of a really crazy looking equation. So what do I say? Compare the target direction with the transverse plane, my y plus, to determine if yaw rotation is allowed. If so, take the signed angle between the current forward and target direction on the preferred up axis. If it is allowed. So no yaw when this is true. So I can actually say if this is greater than that, then I can do yaw. My cosine theta. Cosine theta is the angle between, I guess, my preferred forward, not my current forward. Yeah, it should be my preferred forward and my target direction. Preferred forward dot with my target direction. Yeah, I'm just using my preferences, right? If this is true, then can, okay. Only yaw when this is true. Radius is greater than that. Okay, so if this is the case, then I can do a yaw calculation. The yaw is the signed angle between the current forward and the target direction on the preferred up axis. Current forward, target direction. Okay. So should this be the current forward? I do say on the preferred plane, and this is the preferred plane. I'll say that. If this is the case, yaw will now be equal to the signed angle 2 state transform signed angle 2 and the current forward. Technically, this is the current forward. Maybe I'll write down current forward just to be the negative, so I don't have to keep doing this. Okay, I'll do this. And I also need the current right. Right is 1. Okay. Right when forward is negative z, right? So when forward is negative z, right is positive 1. If I do this, then right is actually left. But okay, so right is correct. Good. Current forward, assigned angle to the target direction on the preferred up axis. I guess I'll just say preferred up. Okay, there is yaw. Take the signed angle between the current right and the preferred right on the preferred forward. This will be the roll. Signed angle between current right and preferred right. On the preferred forward? Yeah. Take the sine angle between the current forward. Switched to Linux last night. Oh, nice. How's it going so far? Current forward and the preferred forward on the preferred right. Good pitch. For later, that's later. I'm ignoring that for now. Obtain a quaternion. Pitch yaw roll. I guess I call this this will be the angular difference. Obtain a quaternion from the current basis. Everything transferred just fine and easily. Drawing my drawing tablet. I have a drawing tablet, and it took me a bit to figure out how to set that up. But it works. Sometimes it's still like weird. I think it's just because it's probably just like Hyperland and how Hyperland works with, I don't know. Sometimes it like feels like it's a totally random layout. Like I put my pen in the center and it's like on the top right of my left monitor or something. I'm like, I have no idea why it's over there. Sometimes that happens and I have to like remember how to fix that. It's just how like the driver and Hyperland interact. Where Hyperland essentially has like a big rectangular canvas, and then the driver has to say out of that canvas where does your tablet screen map to that canvas? And yeah. But additionally, I have to make sure the names are right. It's weird. Conjugated quaternion. By this operation. An Euler angle is just be the angular difference vector. One sec. I'll be right back. Okay, I'm back. My tablet is reading for Android. Reading for Android. What does that mean? Okay. From Euler. YXZ conversion. How about an update that made it Android compatible so that being in desktop mode is in Android mode? Interesting. Interesting. That just seems weird. Why would you want to use that? Besides just like creating a larger screen for your phone. Turning your phone into a tablet, I guess. I mean, I guess that's probably the point of it. You'd be able to use your phone like it was a tablet. How do I get the quaternion? Oh, I think I do this. From a basis, yeah. And the operation is current multiplied by difference multiplied by current inverse, which I am hoping I can just do. Okay, so I have to write it like this. I have to do this times that. Whoops. Nope. Draw on the go. Yeah. I don't know what it is, but there's like kind of this thing where it's like, oh yeah, you can do all your creative stuff on your phone. But then I'm always like, okay, the problem is the screen is just so small, and I would honestly just rather like pull out a notebook and write down whatever my idea is, and then wait till I'm at a computer. I've tried so many times to like do stuff like programming on my phone, drawing on my phone, music on the phone, and every time I'm just like, you know what, the idea is so fresh, I just want to write it down instead. Because I can't make it work. But I guess if you can just make your phone the size of a tablet, then maybe that's okay. When they released Godot on Android, I tried it and I hated it. Like using the editor on Godot on Android. On Godot. That's crazy. Can I just do... I don't like having the op. I would actually rather... This rotates the right quaternion by this quaternion. Let me see if operator... Okay, I need to know which way this is going because it does matter. And I'm going to have to use a bunch of parentheses. Molt is... Or mol? Huh? What? Is this like some Kotlin thing that I don't understand? Why are there two parameters here? Okay, well, let me look at... Okay, never mind. Never mind. Forget that. Just the normal one, please. Multiply this quaternion by that. If T is this and Q is the given quaternion, the resulting quaternion R is T times Q. Mul Q with this. Oh, okay, I get why. I get it. Actually, no, I don't get it. That's just so weird. Oh, wait, huh? Destination. Oh, no, I get it. Alright, but does it look like that? We do W with other X, X with other W. It's in the header file, of course. W times other X, X times other W. Perfect. So times... Wait. Is it going with the times equal? Okay, so right is the same thing. All right. This is why it gets weird, because I have to do this. I have to write that. And then I write this. I guess I don't really have to do that. I mean, okay, maybe that's it. Current multiplied by difference multiplied by current inverse. And then I say, obtain Euler angles from the resulting quaternion. This would be the angular difference vector. So I can just say angular diff will be equal to get Euler yzx, or yxz. yxz. Okay. Divide the angular difference vector by the delta time and take the absolute value vector. And take the absolute value. This will be the maximum rotation rate allowed for the current step. Alright, so I say var max angular will be absolute value over state step. Angular by the delta, take the absolute value. Same way, absolute value first or last. This will be the maximum rotation rate allowed for the current step. Okay, obtain a target angular vector by multiplying the sign vector. The sign vector of the angular difference with the min between the maximum rate and the maximum rate parameter. Target angular vector. Run that by me again. Multiplying the sign of the angular difference times the what? Rotation rate. And this should be the min. No. I do that. Oh, no. Target angular. Now I have this, and then multiply by the target angular min with the max angular. Minimum between the maximum and the current maximum rate, the current step of the maximum rotation rate parameter, multiplied by the sine of the angular difference. Got my target angular. Okay. Rotate the limited target angular vector by the preferred basis. Honestly, I can just say max angular min. Actually, if it's a min f, I can actually just do that. Because max angular is absolute value. Limited angular. will now be the preferred basis multiplied by the limited angular. Move the angular velocity towards the rotated limited vector using an acceleration multiplied by the ground leg factor. The ground leg factor is the number of ground legs over the total leg count. That's it. That's the guess. The guess is that this is perfect. And I guess I mean I could also do this at the end. I'll just call that up. If the target angular is approximately 0 and this is really small, then I set that to be 0. And I'll write this as the last step. As a final step, if the rotated limited vector is approximately 0, and the angular velocity is less than 5 degrees per second, set the angular velocity to 0. That's just a cleanup. That's not related to any of this. Okay, what's wrong with preferred? Oh, because I need to write preferred up. Oh, geez. Okay. Alright, so now I guess I just see what happens. And pitch should be allowed. Well, okay. Let me make sure that this is set. I should just be able to take this out, and that's fine. Target direction is set to that, and then I just leave it there. I will set rotation rate to be, that's pi. That's really high. Max pitch is not currently accounted for. What have I got there? Those are the same values. Okay, what happens? I mean, I can only expect that it's going to do something weird, and I'm going to be upset about that. That's kind of wild. Yeah. This is trying to look at me, by the way. It wants to look at me. What's crazy is that it started so well. It started so well. All right, so I might have an idea. Thinking about it, I might have an idea. So because I compute all of these from, my current angles, it might be that the rotation should be not my preferred basis, because these are all angles according to my current. So it should probably be state transform basis. And just to make, I want to keep total track of this. So this is going to be strikeout. Let Limits variable by the current basis. Okay. Let me see. I guess let me just do some tests. Maybe this can help me figure out what's going on. So you should basically not do anything. Okay, so it wants to turn around and turn upside down, perhaps. Okay. We try back here. All right. So he's trying to direct his negative vector to me. Or I should say, he's trying to direct his positive vector to me. So what is the mistake there? He should be directing his negative vector towards me. Preferred base isn't even used. I guess I'll just count that out for now. Preferred 4 is that, otherwise this is preferred. Okay. I mean, yeah, let me just print out print preferred bases. Oh, y -1? Okay, so that's immediately wrong. Alright, so I did a cross wrong here. I preferred up, preferred forward, cross with my preferred right, which points to me. Oh, that does point down. Wait. No, I thought it was... Alright, food has been made for me, so I'll be right back. But I'm feeling good about this so far. I like when things are obviously wrong. That's nice. Y being -1, that's definitely not right. Okay, 1 second. I'll be back. I'm back. Okay. So what do I have wrong here? I have -1. I mean, I guess I can look at a 3D here. -1 cross with that. I mean, that should give me the up vector. I don't know why that didn't. Preferred forward cross with preferred right. Why does that not give me the right vector? Might, like, point here, point there. I get a vector pointing at me. I don't understand. This is my right hand. Right hand rule. Your finger, the first vector. Your thumb, the second vector. Your middle finger points to the result vector, which says up. Why is it not up? Okay. I guess I need to right hand rule vectors. What am I missing? I've got the Wikipedia page. For cross product. I'm wrong. A, B, no, wait, okay, so forward, right, okay, so I do get, alright, it does come in the wrong direction, so I guess what then I say is this cross with that, okay, so right cross forward, right cross forward. This should give me the correct up vector. Do I specifically say that's how I compute it, or do I just say from these cross to obtain a preferred up vector pointing away from the ground? Okay, so this is... That could have been a problem in the other version, but this is the only cross product I do, so I'm good. Alright, let's turn off the basis. Well, I guess let's make sure the basis is. Okay, what's up? I'll comment that out. And now I do just pretty much don't do anything. Okay. Okay. What about over here? Okay, so he tries to do a yaw and then he flips over. Alright, so far it looks like the yaw is right. It does look like the yaw is right. But I'm guessing there's just a problem with some calculations somewhere around here. So... preferred up, preferred forward, target direction, current forward, sine angle on preferred up. Okay, I'm gonna eat a little bit, actually. I could possibly turn off pitch and roll and see what happens then. See if the yaw at least gets there. I was also just wondering if this is the problem. Because technically this is not rotated. But I guess these are just differences, right? I want to rotate this one by this one by this one, and then this one by this one. It's weird. I guess it's also possible the pitch is just wrong. Yeah, okay. These might just be incorrect. This should probably be the basis, right? And this should probably be... I don't know. I'll see. Okay, I'll be right back. what I actually want to see first is I want to see what target angular says. Let me actually just print all these. Yeah, let me print angular diff here. Okay, so what immediately happened was we did... I mean, first calculation's right, it probably just wants to yaw a little bit and not pitch at all. Actually, it should have done a little bit of pitch, I think. No, because pitch is purely from preferred pitch. So it did this yaw rotation, and then it said... At that point, it decided it needs to pitch and roll. And then it needs to pitch and roll more, and then more. The yaw hit 0. Alright, so this... So first of all, I might have an issue with... Okay. Let me make both of those not happen and see what it wants to do. I'm going to try to stand as nearly center of it as I can. Okay, I'm too perfectly center probably, so a little bit off. Okay. So I do have an issue with that. At the very least, this limited stuff is wrong. Angular difference absolute value over state.step. I guess let me print max angular. Let me do all three of these. Alright, it's going to be too much printing too fast, so... Let me try this. Let me just place myself at a good point, and... I will have it constantly try to look at me. Input, debug, target player. I'll do that. So it's always going to be... Okay. So some of this stuff is running when I don't want it to run. This is all basically input, so in fact I kind of don't want to do anything. Okay. Okay. So I have difference, max, and limits. Difference. I'm just ignoring the 0 or the x and the z components because those are just set to 0 at the end. So max is 0.7 that. And I'm assuming it's just kind of values are really high now. Why are they so high now? Wait, how do I get out of? Do I have to factor in the acceleration? I don't think so. I mean, as long as the acceleration is higher than the rotation rate, it should be able to reach these small values instantly. I guess let me see if that's the case, if it can't reach that rate. What? Diff is 0 in the yaw? That doesn't make any sense. How is diff 0? What? Oh, because it couldn't do yaw rotation yet. It had to wait for the legs to move. So the max is that value, the limit is that value. Which lim is what it's targeting. So it wants to get I'm seeing the difference yaw change slowly. It is doing so many steps. And now it's gone too far. Okay, so immediately it seems like the velocity is too high. If I take max and multiply it by... So I'll do 0.783. Let me see. .013. Okay. So we will travel towards 0.783 as we get further away. Now it's going down. It's going down. And somehow we just flipped instantly. Okay. So this barely changed the velocity. This difference barely changed the velocity. This difference also... Wait, it's becoming more negative. I guess, I mean, this velocity barely did anything because this is like 0.0008 change in rotation. And then this... Somehow at this point it became very different. Okay. So my guess is that because I'm including... What am I thinking there? All right, let me bring this, let me bring that back. Let me bring that back. Whoops. Okay, so it's changing pretty fast right now. And the velocity increased. Okay, the velocity still wants to increase. Okay, so we reached it. But now I can't... But at this point, my velocity should have become 0, I guess. Because I want to, I want to really stop. Now I'm too far. Very slightly. So we want to target that. It's getting worse. So that value increases. It's getting worse, value increases. Still getting worse, value increases. Why is that now? Oh yeah, it's slightly negative. Which it didn't even change the thing at all. So now we're decreasing. Difference was cut in a third, or yeah, by 1/3. Okay, so yeah, the target is quite small, and then we passed it. Okay. All right, so it seems like I'm not quite in. This isn't quite correct for stopping. It may be that this should account for... Well, max angular is this. And then I have... I don't know, because I have rotation acceleration as like a value greater than 1, right? Yeah, I mean, yeah, it's a value greater than 1. Okay, I guess the part that I'm actually looking for is not the angular difference. I mean, it is part of this. So if I look here, I want the smaller value between what I will reach in one step and my real acceleration. But this doesn't account for the current angular velocity. Because I could be saying, yeah, let's keep accelerating because our angular difference is small. But then my angular velocity is like incredibly high. So it can't slow down fast enough. How do I account for that? I guess I have the angular difference. And I guess this is the max angular. So I'm still right. I'm still moving towards angular velocity, or I'm still moving towards a target angular velocity. But that isn't quite happening fast enough. Maybe what I could do is I could sort of like predict forward and take my current basis, rotate it by my angular velocity, and then use those as my current forwards. And then I compute the angular difference between that. No, because that could have a problem of saying I have a really high right or clockwise rotation. So then I compute that and I say, oh yeah, we're actually really close. So if we just accelerate a little bit more or something, I don't know. We'll get there. So then it just continuously spins up and never slows down. Because I think this is actually getting, at least the yaw is correct, except for the fact that my max is too high. I mean, I guess I can take the difference between the max and the angular velocity. And maybe this gives me like my actual thing. Because if my angular velocity is higher than max on like my yaw, if my angular yaw is higher than my max angular, then I definitely want to apply the opposite of that, right? Maybe that is actually what I say. If it's going too fast and they're going in the same direction, like my angular velocity says to do plus rotation and I want to do a plus rotation, if my angular velocity is higher than my maximum rate, then it's going to be a slowdown. So it will be a positive value, but it'll be a value smaller than the max. Okay. So I think it's definitely the case. In fact, I should do this. Okay, let me write it before I continue. What? Strike. Divide the angular difference vector by the delta time, so the maximum rotation rate allowed for the current step. And then I say for each component, of the angular difference, well, let me say subtract from the okay, well, okay, can I move this line up? I actually want to move this line up. Rotate the this will be the angular vector. Rotate the limited angular. I'm keeping track of what I'm doing. Rotate the angular vector by the preferred current basis. Alright, you know what, let me move this back to 13. Rotate the angular vector by the current basis. Subtract from the angular velocity the angular vector. So if I'm rotating positive and if I'm positive and I'm positive, subtract, the difference will be positive. If I am a large negative and a small negative, I will stay negative. If it is a large negative in this, then the sign flips. If the sign flips, yeah, I guess I say for any component where the sign flips. No. Divide the angular vector by the delta time. Essentially what I know is that if I'm a very large negative value, no, it's end minus start, so it should actually be, yeah, it should be the other way around. So it should be so then I say subtract from but this will be the max rate. Subtract from the max rate the current angular velocity. So if my max rate is 2 and my current velocity is 5, then I want essentially -3 out of that. So 2 minus 5 would be -3. If I am -1 and 5, or sorry, if I'm 2 and 3, then it'd be +1. I want to increase 1, right? So this is that, like, essentially, this becomes the move. This becomes the move. Well, not really. The max rate. Wait, because I divide by that. So this is like, I really want to move towards this value. I'm losing it a little bit. All right, that's tough. I just, whatever it was, whatever I was working on there, I lost it. Okay. So, blue line is my current, green line is my target. And I mean, if blue line is my current, then what I could say is my current angular velocity would be something like this. Right, I'm saying my current angular velocity is, I'll say this is 30 degrees and this is 180, so speed plus 150. That's my current angular velocity. So I'm saying my move towards is going to be moving towards this value. But also I have an acceleration that's definitely too high right now. I guess I have to think about... Alright, you know what? I'm going to say scrap the move towards, and I'm going to do it myself, in my own way. So I know that what I want to really do here in this case is I would like to, ideally in this step, apply minus 120 so that my current angular velocity ends up at 30. So that it ends up at this value. Technically, I can do that. So this is my goal to reach in a single step. We'll just assume that a step is, this is like a rotation rate per tick, not really per second, but per time. So ideally I want to have negative 120. But in addition to that, this value, the absolute value of this, is actually limited to my maximum, my acceleration rate, I guess. So in my current setup, I actually can accelerate this far in a single tick, or in over t, so that would work out. But let's say my maximum was 60. My maximum absolute value was 60. So then I would say, all right, take this, the sine of this, and multiply it by the smaller value between this and my maximum rate. So then I end up with, or I mean, I guess I want to do this, right? I've computed my goal. My goal is 30. I want to reach 30 per unit time, which is just my difference. So this is my difference vector value, 30 per unit time. This is my current. So I want to say, all right, well, yeah, okay. So I subtract from max rate. Okay, not really from max rate. Well, yeah, I guess, no. Okay, no. All right, my angular's 1, my change is 1. That's what I want to be at, right? I don't know if I have to do step. I don't know if I have to divide it like that. I mean, I guess it is. Yeah, so I divide angular vector by the delta time. This will be the max rate allowed for the current step. Subtract from angular. Subtract from angular the current I'm saying angular. Angular diff, really? I mean, I'm calling it angular, so I'll just say angular. I'll go and rename these. I don't use angular anywhere else, do I? Okay, I don't know. Okay. Subtract from angular the current angular velocity. This is the or is it max angular? No, I think it's just angular. Because if I say I want to go yeah, I can just make the assumption that this is what I want to apply right now. Let's just say that I always want to do, I want to go to my target in a single tick, in a single step. So then I just disregard steps in this case. So I just say subtract from the angular the current angular velocity. And this is the target angular. I guess this is really the change between them. So call the delta angular. So this is what I would say angular velocity plus delta angular gets me angular, right? That's literally what this is. I'll just say the idea is you add delta angular to current velocity to achieve angular, which will allow the rotations to apply in a single step. Okay. Then this value, this delta angular, cannot have a higher absolute value than it can't have a higher absolute value than the rotation acceleration. So then I say multiply the sine of the sine of minimum between the absolute value of delta angular and the rotation rate parameter. Okay, so now this makes it so we can only decelerate so fast or accelerate so fast. So I'm going to try to think about this in the case of something spinning very quickly like a clock, and its target is its target is forward, but its current forward is always like, it's continuously spinning around really fast. What does the delta angular look like at every one of those steps? So if it's here, the delta might be to be subtract. So, and the actual angular is positive. So it'd be essentially an incredibly negative value. I get a very large negative value, which will slow down. So it's trying to, it's getting closer to that value, right? I guess the idea is it's kind of the same thing. I'm always trying to move my current angular velocity to a target angular velocity. Right? Multiply the sign. Okay. This will be the limited angular. I guess this will be the... Yes, the limited angular acceleration. I'll cut this out. And I'll say the ground. I'll move this up here. Calculate a grounded leg factor as the number of grounded legs over the total leg count. Okay. And this will be add now. Add to the angular velocity the limited acceleration acceleration with the limited angular acceleration vector. If the limited vector is approximately 0 and the angular velocity is less than 0.5 degrees per second, so the angular velocity is 0. So as my delta, then delta will be limited to the angular acceleration. This will be the max rate allowed for the current step. Do I need this? If the delta angular is just already limited, or is computed as the difference, and then when the value is small, then it is that small value. But then when it's very large, it's essentially, it scales up and it stops scaling at some point. So when it's low enough, it'll actually, yeah, so this case should be, it'll accelerate and then stop hard. It should do a hard stop. Okay, I think I can go with this. Still gonna be setting this to 0. That's still correct. There's the angular. I don't think I'm using max angular right now, so I can comment that out. And what I'm going to do is instead say I need to rotate it right now. So I say rotate the angular vector by the current basis. Okay. Right? I don't think I need the maximum rate because I don't see where I'm using it. So I guess I do like no. Subtract from the angular the current angular velocity. Delta angular. If you add this to angular, so let me just rearrange this to see if that's even correct. So dA equals A minus C. So if I were to rearrange this, I would start by adding C to both sides. So dA equals dA plus C equals A. Then I'll do yeah, I mean that's literally it. dA plus C equals A. Okay. Alright, I showed that. Multiply the sine of delta angular by the minimum between the absolute value of delta and the rotation rate parameter, multiplied by the ground leg factor. So target angular is delta angular sine rotation rate. Yeah, and then it won't be a move towards. Whoops. It'll be. I'm just adding the target angular times state step times accelerate. No. No. All right, so this is the maximum that I can change over step, right? So it's probably rotation rate over the step times acceleration? No, because that doesn't make sense. How do I include the acceleration? Limited angular. So this is actually limited. I'll just keep this up. If I divide this by step, then that gets me what I want to change instantly. So I could divide delta angular by state step. I mean, I could probably use move toward. Using delta, right? Or this could be, or no, I gotta stop doing that. I'm doing it where I start thinking about it and then writing code. Okay, well, I'm just thinking about it. So the idea is that delta is now what I would want to be adding to angular velocity. That's what I want to add. But I'm limited by my rotation rate times delta. That's what I'm really limited by. I can only do my max rotation rate times I think that's correct. Absolute value of delta and the rotation rate parameter multiplied by the and the step. Both of those, right? So if I have half my legs in contact with the ground, I can only go half the rotation rate. Let me go do this. Whoa. Okay, so this is the maximum change I can apply. but then I don't account for any acceleration. So how do I account for the acceleration now? I mean, I guess this really is the acceleration. Is it not? Wait, is my... Oh, the acceleration is lower than the rate, which is wrong. Okay, well, I still definitely have a problem where I can see that my... Do I still have output? Is that my problem? The rotation rate is faster than the acceleration? No, I don't think so, because it should be the case that I can take off. I mean, I'm still doing this, and I know, and I can still look at it and see, oh, you know, I'm traveling whatever, right? I don't think this is rotation rate, though. This is delta angular. This is what I would like to perform in a single step, and then I have rotation acceleration. Okay, but I think this... Okay, so I think this is how I include the limit, the limiting factor. Does this still make sense? Before what I just changed, does that still make sense? Yeah, this looks like acceleration, right? If I'm saying delta angular is what I want to change by, then that has to be limited by my acceleration ability. So my change can be no higher than this value. But then additionally, my rotation acceleration, my rotation rate. If I'm over my rotation rate, I cannot accelerate anymore. So that means... You know what? I'm actually curious. And this is why I'm happy that I kept these as comments. I'm just too curious. What if I'll just change this back to target angular. Okay, or not yet, because it's not there yet. Whoop. So I don't rotate it max angular, limited angular, max limited. I need my acceleration to be higher than my rotation rate. That has to be true. I allow them both to be greater. I'll just say the rotation rate is... Sure, 180, and this will be 240. All right. Let me just see what this does. Okay, I have a weird thing going on, but that actually works. That actually does work. What's going on with the legs? Was this like the is stepping thing? Or is rotating yaw? Is that what it is? How is it not failing though? Is stepping. Has desired rotation. I guess I have to write this at the top before I do a return. And then it can become true here if I do that. Okay. Alright, so maybe I don't need to rework that. Okay, it does. It can never reach me though. Alright, let's turn up the acceleration a bit. Alright, this is where he had a smaller... He basically had like a 0.7 there. That's essentially what this had. Walk through you. You're fixing all your legs. This is really delayed right now. Game is paused, by the way. I'm just hovering over this so it can catch up. Yeah, beyond 10,000 it really struggles to... Oh, it's still going. I have the game paused right now. At least I think I have the game paused. I definitely do. Okay, it finally caught up. So the yaw is like an incredibly small value. So it is still calculating, but it's... I mean, it also should be... It is less than 8.5 to the negative 5, which is this value. Or just 8 to the negative 5. It is less than that, so it is zeroing it. Okay. Also, the difference reads a very high value here, so these are definitely just kind of incorrect. What is that copy? What does it want to do right now? It wants to turn 10 degrees? Interesting. It wants to pitch and roll 10 degrees. Oh, I guess that's in... Actually, I don't know what that is, because that's relative, isn't it? No, that is relative. Okay, well, anyway, it's actually working. I just had the mistake where the angular velocity, the angular acceleration was actually not low enough, or not high enough, to account for the fact that it could rotate really fast. So. I should have checked that. I should have actually totally verified that before I went on with this. Okay. So I'm going to write this back. Write this back to how it was. Which actually I might just be able to do Control Z a few times. I moved a lot of stuff around to get that. Okay. This is before I even had the word minimum or delta angular. Alright, and that's all the history I get. So rotate the angular vector by the current basis. That's not what I do. I don't do that. Yeah. Well, yeah, either way. At least for printing, this is probably better, because these will have the same sign in that case. Or one second, I gotta fix the window. I'm getting my arm burned. It's actually just been getting so warm in this room because it has like a huge window and it's on like the hottest corner of the house. I have to just totally go dark at this time of day, fortunately. All right. I think he actually did like times 0.3, honestly. I want to see what that looks like. I mean, this is kind of like the bounce thing, isn't it? A bounce parameter, an overshoot parameter, or like a 1 minus that value. Or, I mean, I guess it could also be like large. Like, what if I made it larger than, what if I did that? Yeah, this is like my overshoot parameter. Okay. Let me match. I just want to really match this. So I mean, it's working, but I want it to match, so when I go here and I go to add something, I know I can read through it, and this matches the code, right? Divide the angular difference vector. This will be the angular. I'll just call it the angular vector. Is that what I call it? Yeah, I'll just call it the angular vector. What? Angular vector. Divided by the delta time. This is the max angular. The max angular for the current step. Target is then to rotate it. This will be... Well, actually, I say rotate the limited angular by this. Yeah, okay, it's still a little bit out of order. Obtain a limited angular vector by multiplying the sign vector of the angular vector with the min between the max angular absolute of the current step and the rotation rate parameter. This will be the and then rotate the limited angular vector by the current basis. This will be the target angular. This will be the target angular. I'll say, yeah. Move the angular velocity towards the target angular vector multiplied by the overshoot parameter using an acceleration multiplied by the grounded leg factor. Acceleration multiplied by the grounded leg factor, is that right? What if this is small? Oh, it's like really soft. Can you still pick up speed though? No, he's kind of lagging behind. That's good. Yeah, my mistake was that my acceleration was smaller than my rotation rate, which caused at least the yaw to like jitter back and forth. And fortunately I caught that before I started doing a big change. Well, I already wrote the big change, and then I was like, before I tested the big change, I was like, what if I just did this other one? What if I just fixed the value first and then it worked? Yeah, but this, I mean, I guess it probably needs to be at least like 0.5. I don't know. It's a bit strange though. I don't know, maybe I'll just limit to like 0.1 or something. Or like 0.2. I don't know, this is an overshoot factor. So the yaw works. The yaw works really well. I guess I'll put this up here. So rotation rate, rotation acceleration. Say probably 270. I won't do or greater. I'll say 5. I wonder if I could say this times 1 over. I'm just like totally guessing something. Overshoot. Does this fix that so it should still slide in, but it can still reach a top speed? So if I spin around, it should still like pick up. It's definitely not like doing 180 per second, but it is also limited because it has to stop for legs to move. Oh, this should actually be multiplied by rotation overshoot. Whoops. Alright, yeah, that's about what I saw when it was like at 1. So if I did 0.2. Oh yeah, it's going pretty quick still. But it does kind of have that problem. Maybe I shouldn't be doing that. Oh no, it slides in. It definitely slides in. But then you can still pick up that speed. Sort of. And basically no overshoot when it was done. Okay. I can put that there. What if I did 1? Yeah, I mean, it's pretty crazy. So you probably want this to be less than 1, honestly. I'll say 1, and then or greater, if you really want to do something ridiculous. I'll start at 0.2. Ain't no way. Those look good for now. I still have a problem with pitch and roll, but I can figure that out. Okay, are these... Honestly, I want to send this code because it's so close. It looks like it's only a problem of the angles being calculated wrong. Because I'm looking at the yaw, and the yaw does exactly what it's supposed to do, which I can't imagine why the pitch and roll would not do what they're supposed to do. Or I guess it's also possible that adding those in there makes yaw break or something. Move the angular velocity towards target angular vector. Sign of angular vector with a min between this and the step rotation rate parameter. And the rotation rate parameter multiplied by the inverse overshoot parameter. I'm home from a 2-hour bike ride. That is a very long bike ride. I think I used to do like an hour bike ride to school though, for like a few months, one time. And that was both ways. I was crazy. I don't know why I did that, but I enjoyed it. It was not an easy bike ride either. There was a lot of up and downhill. So it was also exercise. Intense, pretty intense. Some of my close friends were crazy. Yeah. Every time I like remember that I did that, I can't believe I did it. Because it really was the case where I would like wake up at 5, I would leave at like 6, and I would bike for like an hour and a half to get to school before 7:30, because that's when classes started. And it was, yeah, it was long. It's a long bike ride. You could have taken a bus? Yes. Yes. Where I lived, school buses were servicing me. I would ride my bike past the bus stop. I think what it was is maybe it was like my parents showed me like, hey, if you want to take your bike to school, we're like they took me and we rode our bikes to the school. Said, all right, this is the route, so if you want to take your bike to school, this is where you would go. And I did that. I just did it. Get on the special ed bus. No, they had a normal bus, regular bus to take me. Actually, I think it was like for an entire school year, in fact. I don't think it was... No. I took my bike while I lived in that area, and eventually we moved to like right across the street from the school, so I could just walk. That's why I stopped, is because we moved so close that I could literally walk. I could see it out my window, basically. Yeah. Yeah, the exercise was very good. I really enjoyed it. And I was also fortunate because in my high school was actually in walking distance too, although it was probably like 10 times further. I also walked there. Sometimes I would take my bike if I was late. But I rarely did that. I would just walk and be late anyway. Because I don't want to deal with a bike. Was so close to school, he owes. Yeah. He owes. That was nice. I like that walk too because where the sun rises in the morning, it was there were no buildings blocking that direction, so pretty much while I walked to school, I could watch the sunrise during the time of the year that the sunrise was happening. Then I'll try this joke again soon. Yeah, that was really nice. I really liked that. I like that I took my bike very, like, probably about the limit of what I could physically do, honestly. Because there was times where I would be, like, near the end of that, or, like, near the middle of that bike ride, I'd be like, God, I am so... This is such a hard part. It's just too steep or something. New episode of Digital Circus today. I don't know what that is. I don't watch episodic stuff. All right, is that it? Oh yeah. So I'm trying to fix that now. Okay. Let's get that fixed. Look at me. Yeah, okay. So alright, so weirdly, the pitch wants to jump up and down by large factors every frame. Okay, now it's... Okay, so the roll is getting worse, and then the roll value is getting worse. Right? So that's at least probably where I can start. The roll is definitely getting worse, and then the value is just getting higher. I mean, I guess it makes sense. So it's probably that the roll is applying in the wrong direction. It is on the preferred forward axis. So possibly it should be the negative angle. All right, I caught it. Okay, so the value of the roll is continuously increasing. It's also flipping a lot, which is bad. It's flipping by very large values. Okay. Okay, I mean, let me check what my current right and preferred right is. So my current right should be +1. My preferred right should also be +1. That's what I expect to see. That these have the same value. Pretty close. Pretty close. So... It's also flipping over really, really fast. So I would expect to see a negative value for roll. At least in my brain, that's what makes sense. I should see a negative angle. And I'm seeing a positive angle. All right, so that's I guess that is kind of the problem. I am seeing a positive angle. So does this mean I probably should use negative? I should put a negative in front of this? I mean, I guess so technically, because it's supposed to be on the positive. I'm rotating on the positive z-axis, not the negative z-axis. Right. It doesn't seem right, though. It seems like it's flipping kind of incorrectly. Oh no, because my current points... Okay, so my current is slightly pointing up, so I want to rotate down. My current's pointing down, so now I want to rotate slightly up. Okay, and it flips. All right. But it does seem unstable. Yeah, it's shaking. Okay. But it looks like the roll is correct. So now I'm going to look at pitch. So current or preferred forward and current forward. And this will be the rotation pitch. Okay. So currently it's pointing slightly up. So it wants to rotate down. That makes sense. It's pointing slightly down, so it wants to rotate slightly up. Sure. It has this weird jitter though. It definitely has a really intense jitter. I don't understand what it's doing. Alright, I gotta take the dog out. I'll be right back. And I'll be thinking about why it's possibly jittering. I'm back. Alright, so my first thought immediately was maybe this. So I'll change this to 1/1. And just see what happens. Okay, it's still vibrating, so that was not it. And I don't think that should be it. So, okay. My other thought was the preferred is changing. That's preferred forward. Which is wrong, actually. Huh. I do see it. The preferred forward is not changing when it should be changing because we're trying to turn a different way. So maybe this should be current forward. So this, okay, so this is signed angle to target direction. But preferred forward should probably be in the target direction, but the target direction flattened to, okay. Okay. If I don't allow yaw to happen, let me turn off yaw. If I turn this off, it should pitch up and down correctly. Or well, okay, it's gonna try to match. Okay. Let me say signed angle to target direction. Just as a demonstration. Okay, so it's totally freaking out and can't decide which way it wants to go. Okay. Also, it's the fact that preferred, well, I mean, wait, what? I just saw a nan appear. Preferred current. Preferred current is a negative value, and then it says we want to rotate up some amount. I look at it from here. I'm doing the vector from... Yeah, the preferred and the current are really, really similar on the right axis. This is roll, right? I'm looking at roll right now. Or I'm looking at pitch right now. So pitch is actually... Yeah, negative. We go down. Why is my preferred... Wait, what? Target direction. Current forward. This is roll. Wait, what? No, this is pitch. So preferred... Okay. Alright, I have a weird transform here. I don't know why I have a weird transform, but I do. Alright, so I am directly in line with the creature crawler. Let's put this over there. Or 30. Make it 30. Okay. Why is it not... Huh? This is pitch. Target direction. It should always be trying to look at me. What is it doing here? Did I turn this on? I did. Whoops. Turn that off. Why was it shaking? Wait, this is really weird. Why was it shaking? Alright, it's gone insane. Okay, it figured it out. But it still jitters really badly? Okay. Alright, but I was just showing something. Preferred forward. Um... Yo, huh? What's the problem here? Alright, let me just go back to normal. What's the actual problem here? Everything is shaking. Whoa. Alright. Weird. Weird. The yaw works, but as soon as I incorporate roll and pitch, it fails. I think it is just because the preferred forward isn't exactly correct. At least I think in both of these cases, the preferred right and the preferred... Okay, so the preferred right is probably... Or the roll probably stays like that. But then... pitch... Well... Okay, I think it's that it thinks... Okay, so once we include the yaw, the preferred right and the preferred forward are now not aligned with the current right and the current forward. It should happen that the current right, or the preferred right and the preferred forward, after the body rotates on yaw, still somehow aligns itself with that yaw, I guess. So maybe what I do is I say... I could have preferred right rotated by yaw and preferred forward rotated by that. Or maybe not. I could. I think that would probably make it a little bit better. Trying to visualize in my head here. Maybe I shouldn't be doing that. Hang on. I gotta think about this properly. So the problem right now is that preferred right and preferred forward are not actually aligned with current right and current forward, but they should be. They're not because... I guess that's the preference when it's not looking anywhere. But when it wants to look somewhere, it should say, okay, here's my forward, or here's my forward and my right. I'll just do this. Forward and my right, which... I wish right hand rule worked with the thumb and then the middle fingers where it points. Whatever. I don't know how I thought of it like that either, but I feel like that one just is more intuitive. You make a finger gun and you point these where you want, where your vectors are. Pointer finger is your first vector, thumb is your second vector, and then your middle finger points that way, but that's not how it works. It's pointer finger is where you want your vector A, middle finger is your vector B, and then your thumb is your cross product. Okay. Anyway, if these are my preferred values from the legs, and my yaw tells me to turn, it should turn like this, right? So maybe what I say is I take my preferred right and my preferred forward, on my preferred right. Maybe I do just take both of those vectors and I rotate them. by the yaw using my my current up, because that is how I will rotate it. All right, let me try this. Does this make sense if I do this? My preferred forward. Okay, so here's what I'm trying to do. I'm trying to rotate my current forward to this direction on this axis using my preferred up. So if I do that and I'm looking up, I'd rotate like this. What this? Let me check what this does. He does have this, which is essentially just trying to get an angle between... Essentially just getting, yeah, target Oilers. But I can directly compute that. And then he gets the difference between those two. What should current right and current forward, which axes? I have like, I have two options here. I rotate them by the preferred up, so they both stay in the same plane, or I rotate them by my current up. All right, let me just think about pitch. Maybe that'll help. Just think about pitch. I'm on some incline, and I want to turn 90 degrees right. So I make this turn. I guess what's my preferred? What would my preferred right be? I guess my preferred right should actually stay in the same plane. Shouldn't it? My preferred right should stay in the same plane. Because if my legs are on an incline, that plane stays the same. Okay, so I think that's, yeah. Okay, so it still shakes like crazy though. So what looks like is happening? My preferred is 0. And this is pitch. So that's not right. Pitch should be going down slightly. Yeah, this is pitch. It should be going... Well... Wait, why does it think it needs to... Oh no, it kind of does need to rotate. This is weird. Dog. Yeah. I'm not sure. I'm confused. I actually am confused. Shouldn't my... Wait, should these be... Huh? Okay. My thought was wrong there. Why was my thought wrong there? Okay, just going back to square one. My pitch should be computed to be an angle. Essentially the declination from my preferred forward, whatever that is, or from my current forward to my preferred forward, using some right axis. It might be incorrect to use... It could be wrong to be using... preferred in this case. Or at least preferred here. This could be wrong. Because if I'm applying it... Yeah, this is what's weird. If I'm applying the rotation using my current transform, then shouldn't I be checking the difference using my actual up and not any of these preferred? Yeah, so why... Okay. Shouldn't I? I mean, I guess in this case it makes sense because I do have a preferred up. My actual up should not be... My actual up vector is going to continuously try to point here. That's essentially what I want it to do. But this might be wrong. This use here might be wrong. Yeah, I think this is correct because I say if I can't, if where my feet currently are, I shouldn't be looking up at a thing, then I'm not going to try to look up at the thing. Or I'm not going to try to rotate to the thing if it's too far above me. But maybe this should be the current right sine angle to preferred right, which preferred right is going to just be to settle myself on the ground. But it should be on my current forward. Should it not? It should probably be on my current forward. Which means up here this is probably wrong too. This should be current forward sine angle to that using my current up. Which I don't have a current up. And this should be my current right. So I still have the preferred forward being used here. I still have the preferred right here. So I'm trying to align my current forward to my preferred right, my current right to my preferred right on this axis. I'm trying to align my current forward to this forward on my axis. So it's still wrong. It's still shaky and crazy. Why? Why? Do I still have to do that rotation then? Man, voice actors are completely done. I was testing Voice actors are done? No. No. There's always the weird stuff that totally throws it off. I'm totally confused. It's because this still isn't this is not accounting for the fact that I'm looking down. It's so weird. Damn. Okay. Well, I was wrong. I was wrong. And I mean, it doesn't. You can't direct. The problem is you can't direct that. You can't tell them to say in a different way and actually get it. You can't say, okay, but make it sound like this. Like, and even then, you also don't get anything inspired. They're not gonna talk back to you and say, I've been reading the script. I think it would make sense to do this. Also, as far as I understand, we're still ahead on AI being able to detect other AI stuff. It has not flipped around where an AI can't detect AI stuff. So there's that as well. You'll always be able to run the output through a checker and it will tell you like a percentage, a probability that it was AI generated. What's okay? So the problem here is that I think it's just a disconnect between my preferred values. The angle is wrong. I think that. All right, that's what I know for sure. The angle is definitely wrong. No, it's still just word processing. I'm just gonna say I don't want to talk about that. I'm really trying to stay focused on this. All right. I really need to make this work. I really don't care what AI is doing. I'll be back. Alright, I'm back. Here's what I'll say about AI. I'm not going to use it, and if I find out you've used it, just like you as in like a general person making creative stuff, I'm not buying your product. I'm not buying your art. And if I already bought it, then I'm gonna complain loudly. Okay. So the angle is wrong. Why is the angle wrong? I was thinking it's wrong because I'm checking an angle difference between my current and my preferred on a preferred axis. And I thought, okay, well, that preferred axis isn't changing, isn't updating to what I'm currently looking at. So let me make it update to what I'm looking at. And then I did that, and it still was not working. It still wasn't working. What if I use A to turn my voice into a female voice so I can dub both female and male characters? What did I say? I said, I'm not going to use AI, and if I found out you used AI for anything creative, and you as in a general person doing creative work, I'm not buying, and I'm not promoting. So I would be upset. I think really the only, probably the only valid use is placeholder, and you never distribute that placeholder. But even then, it's like, it would probably be better if you just didn't have the audio at all. It'd probably be better if you just didn't have the audio. If I was gonna go like to an investor and say, here's my game, and I was missing a female voice, I would just say, by the way, I don't have a voice for this character yet, so it's gonna be subtitle only. I'm not gonna say, all right, well, let me record my voice and convert it into a female voice for the investor. I wouldn't do that. I wouldn't do it even in that case. But I could understand using that if like it's personal and you like really want to know if a female voice works on a character. I don't even know. Just get a voice actor. It's it's cheaper than you would think for short stuff. Have a friend do the lines for free, just to see if you think you would want a female voice or a male voice if you're picking between two voices for a certain character and you can't tell which. So it would be okay if I use a voice changer but not AI. Well, see, voice changer is different because that's very deterministic and it was not trained on anything. Someone went in there and said, oh yeah, let's EQ this part out, let's EQ this up. Like, that's what a voice changer does. It's like an EQ. It doesn't do any analysis on your voice. It is a filter. An actual filter. Not a trained neural network filter. All right, I'm done. I'm done with it. So I really need to think about this. Okay, so let's start over. So I've noticed that the angles are wrong. The angles are wrong because it's jittering. It shouldn't be, if the angles were correct, it wouldn't be jittering. It also happened because it started to incorporate pitch and roll. So let me just quickly double check that. If I set pitch and roll to 0, I don't get... Okay, so it's happened. I've done something. I think this is because the target forward is not clamped, right? Okay, so when I do this, it doesn't jitter. Okay. But when I don't do this, it does jitter. All right. So maybe... I guess let me look at this. Yaw. Preferred... I guess this is target direction. And this is current forward. Yaw. So I'm standing perfectly in front of it. It should not be rotating at all. I know because I spawned myself in front of it. Okay, so preferred comes in, and I get a rotation, a suspicious rotation. You think because you know you don't make sense? What? Okay. And I'm currently not zeroing the Y, right? Yeah, I'm not zeroing the Y. Okay. But I get a rotation here. How am I getting a rotation on the yaw? That's the question. Why am I getting a rotation on the yaw? I shouldn't be. So to me, this tells me that signed angle 2 possibly... I mean, at least the way I think of it is that if I think of... Let me demonstrate. If I think of this function as essentially taking the normal plane, pretends the circle is the normal plane, of the vector I provided, it gets 2 points. These points can literally be anywhere, okay? They can be like here, and this will be my current, and this will be my target. Okay? But this plane... Also, I'm on the paint layer, which is not what I meant to do. Let me try that again. The vector layer. Alright, I'm on the vector layer. Let's make that 2. Why does it look like that? Whatever, I guess it probably works, actually. Yeah, for some reason there's like partially transparent. I don't know why. I guess I need to make them 2 so they're not partially transparent. Okay. But what I imagine this should be doing, or what I guess what I really want it to be doing, is taking my current... Okay. Back to 2. That's why I have to right-click that, because it just clicks in the middle and it sets it to like 500 something. And then I have my target. Okay. So these are basically allowed to be sitting wherever I want. But I project them down onto the plane. This is what I imagine it should be doing. So projecting it down onto the plane and then normalizing that vector essentially just means taking the vector in the middle that touches the circle and touches the edge of the circle and intersects that. And then what I do is I grab this angle. The angle between these two vectors now is what I imagine this should be doing. Now, I can reason about how I should do that. Essentially, I would take both vectors, I slide out the normal vector, I slide out, the axis vector from these two, so they both get flattened to the same plane, the plane that I've defined that to be on. I normalize that, and then I guess I would do the A cosine of the dot product, and then do some math to figure out like what's the shortest angle, right? So like a vector. So essentially what this means is if I do a dot product between these two, I might get like 0.5, but 0.5 could be in either of these two directions. So 0.5 could mean my goal is here or here. And I would have to do some kind of math to figure out which direction that actually is. That's what I imagine it should do. So let me go look at what signed angle does. I don't know why signed angle would not give me that value, but it feels like it's not giving me that value. And I think this one's actually here. No, it's not. Okay, it is on the header file. That's what I believe it should be doing. Okay. So what does this do? So it crosses this vector with my 2 vector to get me an axis, essentially. And the unsigned angle is so it gets me a perpendicular vector, and then the unsigned angle is a tan 2 of that. And the sign returns literally positive or negative for the axis. All right, I want to understand what the angle between 2 vectors is. Sure. Finding an angle between two vectors is not hard using the cosine rule. Avoid calculations to just square root an arc cosine. Um, Is this, I mean, this is like a 10-year-old answer, isn't it? Yeah. It's actually an older answer than that. I can just open these, right? These don't, yeah, okay. What's going on? What am I doing? I'm confused. Do these give the same result or what? What are these numbers? Okay. Radians, diamonds, degrees. Yeah, what are these on the other side? I don't understand this. Alright, never mind. I don't know what that is. Like, how do you, how do you do this? We're going here apparently, because everyone else is like has some like weird extra thing. All the other results have some weird extra thing.
About finding the angle between two vectors. So let's say we have
I can speed this up though.
U and vector v. How can we calculate the angle between those two vectors? What do we need to do? It turns out that there is a formula that can help us do so. Cosine of the angle between the two vectors is equal to the dot product of those two vectors divided by the magnitude of u and the magnitude of vector v. Now, to actually calculate the angle, you need to use the arc cosine function of the value that you get with the fraction on the right side. So once you get an answer, you need to take the
All right, let me see this. Here's what I think this should give me. I think this should give me sine angle 2 is this result. Okay? Here's what I think it should give me. I think what I should do is I should take my forward and my target direction and flatten them to the plane of up. Okay? So do A will be equal to current forward slide preferred up. And B current target direction slide and these should both also be normalized. You're in a different room, it looks better. No, it's the same room. Hey, Serpent. I do have the windows closed because it gets way too warm if I leave them open. No longer in the white void. Yeah. So I slide those out and then I normalize the vectors, and then I would do... I would say angle is just going to be the A cosine of A dot B. And then on that axis, what does this really mean? Because now I need to know if this is a positive or a negative rotation. I guess it depends on my current forward. Yeah, I guess I say if my current forward dot with up is, I mean, I guess I just follow exactly what they have written, right? If the sine is negative, then it's a negative angle. If it's 0 positive, then it's that. Yeah, okay. So I would do current forward dot preferred up is less than 0, then angle is negative angle. Print sine angle 2 and then true. I don't know. I'll just do this. What do I calculate it to be? And then I will comment those out. So sine angle 2 is 0.1, 0.01. Angle is 0. Yeah. So and it is shaking right now, so it's probably part of it. But it's also never going negative, which is probably strange. Yeah, mine is never becoming negative. Okay. What did they check? Oh, they're doing the cross. Okay. Oh, what's a flesh tuber? Do you review flesh? No, it just means I am actually present in front of the camera. Okay, this is like, I think it's blown out because the light behind me. 1 second. I'm just noticing it's just been staying dark. And now I'm in slow motion. Well, that's the best I can do. So I would say that mine is not working. I guess I am doing the cross, right? So yeah, I would actually cross these two together. And then I would compare that. And that's what actually dictates which way I'm going. Okay. So yeah, I would just do the cross. Yeah. A cross B. And then I guess I will print both of these out. And I'll move them up top so I can see it before the print. My preferred, my current, and then my custom angle calculation. Okay. So my custom angle says nothing right now. And signed angle 2 says a quite large value. So my current is slightly, yeah, so my preferred is to look down, or what is this? This is yaw. What? Either way, here's the thing. These two are different numbers a lot. These two values disagree constantly. They actually always disagree. Sometimes the angle says, no, we don't need to turn, and then signed angle 2 is like, we gotta turn. So, as I said, this is what I imagined it would do. It would take these 2 points, flatten them to the plane of the normal that I provided, normalize them, then compute the angle between those two, and then it would be a signed angle using, you know, is it a positive or negative direction, right? So, is signed angle 2 wrong? To me, it feels like it is. Because I would think I would think my goal here is to line these two vectors up. So even though what obviously would happen is this would rotate over here to be that. Obviously what would happen is these 2 points are not like in the same depth, but their normals would they'd still sit on top. They would still end up having the same normal in that plane. That's my idea for what this should be. So, from my perspective, signed angle 2 is incorrect. It's giving me the wrong values. This is what I think the angle should be. I slide out the axis. I normalize the axis. Or I slide it out. I normalize it. Because... yeah, what does it say? When viewed... So, okay, so here's a test. Here's a test. Here is... yeah, I mean, literally, here's a test that I know I can run right now. So... let me demonstrate what I would want to happen. Let's say I just keep it simple and I have my goal vector is here and my current vector is here, right? So I could say, hey, my signed angle between these two, okay, I actually wanted to layer them on top of each other. My signed angle between these two should be 0. So essentially what I can do is I can take a vector that is not normalized, normalize it, and then take that same vector and do the angle between itself on any axis, and I should get 0. Okay, well, not any axis. Looking from the top. If I give the normalized vector, I guess the well, yeah, okay. So here's my test. I'll say A. This will be my current vector. It will just be I'm just gonna say like 0.5 vector 1 times 0.5, and then I will normalize this. And B will be vector 3 of all right, let me say this. This will be more obvious. So the y component of each of these are the same, or they're different. The x and the z component, essentially, if I were to look at this from the top, the two vectors would appear to be the same except for having a different length. That's all that would change. This one would be a larger length, and this would have a shorter length when viewed from the top. This will be signed angle to A, signed angle to B. And I would expect this to be 0. Right, this is what I expect this to be, is this should be 0. Honestly, today might be a compile day. I can actually technically bring this up to 7 because I didn't compile yesterday. But today could be a compile day just to get a signed angle to function that I think actually makes sense. I don't know. Maybe I don't really need to do that. I can just have a function that computes it. Or that does some of this extra stuff for me. But this is what I think it should be. So then I would take A is a slide. I'll even write axis here. Because if any of these are like vertical on the axis, then it should say 0. Like you can't rotate to match them. They already match, essentially. And I don't really need that. I can just see these. Okay, so I would want signed angle 2 to give me 0. Well, I know that, at least for my example, right? I guess maybe 0.5 would probably make more sense to do this. 0.5 is, whoops. 0.5 is going to be like 45 degrees when you normalize it. But because this one is slightly projected in that axis, it loses some of its length when viewed from that axis. So it would look like this. So I would say the signed angle from between these two is 0. Or just the angle between these two is 0, regardless of sign. This one is my current and green is my target, is the idea here. But it'd be 0. I would want no change to the angle. Crawler. It's just the crawler. So my angle I've computed to be 0, and signed angle 2 is 0.6, which is really large. That's a very large angle. That's actually kind of crazy how large that angle is. 0.615. What is it? Like, how many degrees is that? Did I say 615? 35 degrees. That's just not correct. That's not what I want. That's not what I want. So, why is it written that way? I feel like I can't change that because that's definitely used probably in some other math. But I mean, like in theory, I could add my own method, but I probably shouldn't because I don't know. Those classes are weird because they're a bit different. I don't know, maybe I can. Maybe I can. Maybe there is just a bind static at the bottom of this file. Yeah, there's no binding, so I don't, unless it's in the header file. No, there's no binding. So yeah, I have no clue how that would work to actually add those in, so I can't add them in. Yeah, I want angle to be 0, especially if one of these is on that axis, which is just an edge case off the handle, because normalize will probably give me like an infinite vector or something. I mean, let's see if I have just that. What does this say? Okay, it says my angle is kind of something crazy. But it should be 0. I guess it's because B becomes 0. Return 0 if length is 0. Yeah, I guess. So yeah, I just think it's pi over 2 is what that's doing. Yeah, okay. So I've shown that this is how I want the calculation to go, and that's not how the calculation goes. And in fact, this is probably easier because there's no a tan 2. There's an a cosine. A cosine is probably better than a tan 2. There are slides, so there is a bunch of length testing, but I can probably simplify slide. I'll just look at it. Because I'm sure part of it is that it checks, it computes the length, and I know the length is 1. Times the dot. Oh, so actually slide doesn't include any length check. It does have to be a normalized vector. Perfect. Perfect. All right, so I'm just going to write my own function. My own signed angle 2. Actually, maybe I could look at this a bit more and see how they possibly do this. Maybe it's in like some kind of math thing somewhere. Math defs? No. What does this say? It says nothing. Okay, interesting. Maybe it's core bind. That would make sense. This file is too short. There's no way. Oh wait, hang on, I see vector. No, those are just methods that return a vector. Alright, let me for signed. Variant call. Oh, so it actually might be really simple. Wait, does anything use signed angle too? That uses signed angle too? Node 3D editor. Editor what? Tilt. Yeah, unfortunately it's used, so I actually can't change it. But what I could do is make my own method that does this. And then I would just have to bind it there. I could even be cheesy and say signed angle and then number 2. I think you can have numbers in methods. Can I have numbers? Can you put, does C++ support numbers in method names? Alright, so here's what I think I want to do. I think what I want to do is just say signed angle and then number 2. Signed angle 2. Or just signed angle. Because that makes sense to me. Alright, I'm going to do it. Today's a compile day. I want that so much that I'm going to put it into an optimized path. So the first thing I do is I'll just write it here. First is I want to check where I'm at. My branch is on origin planet game. What have I changed there? Oh yeah, I was trying to do that. I'm gonna just do git restore. What are the options here? Compat include, of course. Why is build untracked? Oh. Because I just kind of forgot. Also, it actually needs to be renamed, in fact. Oh, bin zombie game. That's not where it's supposed to go. out bin planet game. Also, do I have custom here? No, there's no custom. What's version? All right. Let me double check this. Because I say outbin is this dot planet game. Cannot locate output build. Ah. Wait a second. Oh, wait a second. Is that what the issue has been? I don't have the... Wait. Is that why I'm seeing Jolt Vehicle appear? I might be in a bit of trouble, though I'm not sure. Where's my version? Just close that. Go here. Go here. Okay, go back. New tab. Here. Okay, so I only have those. But I think what I've done wrong is I don't have the custom here. And because on my side, I actually still have this build output sitting there. It's been linking the wrong build output. So yeah, let me say I've been with custom suffix. I'm gonna say custom suffix. Okay. So I'm pretty sure what's gonna happen is I'm gonna do build. I'm gonna do ./build a, and I'm not gonna write that. I actually am just going to add it as a new thing. Close that. It shouldn't do anything. Okay, maybe it will because I changed the skeleton file, but that should be the only thing that it changes. But then it's gonna say cannot locate output build, unable to link, is what I expected to see. Because I've never built with that custom prefix, suffix. I've technically just been building the normal file. Yeah, so it's only that file. And it's gonna tell me cannot locate. Okay, there it is. All right, so what I need to have is I need this custom Oh yeah, I'm on that one. Cool, right there. Custom.py. Extra suffix is kind of all I do there. Oh, and then I need to say precision double. Oh, jeez. How did I miss this? And I'm sure it's going to work first try, so I'm not even going to worry about that. But I'm going to leave it on production. Oh, jeez. And then I have to change the get ignore to get rid of this custom pi. All right. There we go. I'll let that line out. So I have custom suffix, unignoring custom pi. All right. Now, I go in here. I am just going to name it that. I'm not going to say that. I'm going to say plain. Actually, I guess I will just call it axis. I don't know what V-array is doing there, but it needs to be there, so. Then I go here. It says force inline. Great. Two. All right, so what do I want it to do? Here's what I want it to do. I want it to slide the axis and normalize it. Slide the axis and normalize it. Well, I guess before I normalize it, I check if they're approximately 0, probably. So I'm just gonna read all that. Is there like an is normalized or something? Somewhere around here is slide, which probably has something that I want to steal. But what about is 0? Why do they do that? They do it like this for some reason because they're just insane. One of the rare times they or it's not here and I'm just getting tricked. No, it is here. Is 0 procs. Okay. I gotta let the dog out. I'll be right back. I'm back. All right. So yeah, I'll do like the is 0 approx. on these. Yeah, that'll be my idea. So what I do is here, not there, here. Not there. I'll just copy. I don't think the copy works quite like that, though. Yeah, it didn't work. I gotta do this. Okay. So, I treat both of these as normalized. I guess I can write slide has this. So I have to be normalized and they both have to be normalized. Where am I at? Not is normalized. Zeros and P2. The normal vector I guess I say this vector 3. I guess I say the vector 3 must be normalized. And then the vector 3 P2 must be normalized. Okay. And the axis must be normalized. Alright, so vector 3 A, I guess will just be slide axis. Of course I need that. Vector 3 B will be T2 slide axis. And then I guess I can just do this here. If A is 0 approx, what is it? Like that? Yeah. Turn 0. If B is 0. Okay. And after all this, I do A equals A. Okay, I think that normalize actually operates on the vector 3 itself. So I don't think I have to it's different for... Oh wait, there's normalized and normalized, which both should be in this, in here somewhere. Because I can just use normalize, because normalize with the D will create a new vector. I just want to do this one. Yeah, see, it creates a copy and then it normalizes it. So yeah, I can just do dot normalize. So I'm not making a copy. Where am I at? Should be around here. There it is. What does cross do? How complex is cross? I think cross is also just doing some multiplies. I think it's really, really simple. It's right at the top. Oh, it's like the dot. No, that's really weird, actually. All right, dot is simpler, I think. Or what I'm writing right now is simpler. Normalize these. I did the slide. I do the check. Normalize. And then real T angle will be, I think it's like math. I'll probably do like math A cosine. Wait a second. If I have to call math, oh no, they call math up here. Never mind. Math A cosine with a dot B. Right? And then I say if a cross B, if these are the same vector, then they're parallel, which means I get a zero vector dot with the other thing, which is also just zero. Okay. I could possibly cross them first, and no, yeah, it does need to be like this. Okay. Also, this is wrong. This should be p-axis. A equals slide this one. P2 slide p-axis. If this is less than 0. I guess I can write it as a return. Alright, so that's my version. That's the version I want to have. Dog? You're alright, buddy. Okay. I gotta take my dog out again. I'll be right back. I'm back. Okay. Sine equal 2, I've got that there. Sine equal 2, I've got that there. There it is. I don't care about tests. I don't care about that. And then I don't care about documentation either, honestly. Well, maybe I do. Maybe I do. I'm good. Adding the method definition and then adding the bind there. That's literally it. Okay. And that should also work. Yep, it's gotta do everything. Because I'm doing production and double, so. Alright, but compile days. 7. I actually made it 7. Though I'm pretty sure I've honestly done more like 20 once. I just like forgot so many times to mark it. So. But of the days that I remember to count, 7. And honestly, this one is actually the longest time I've gone. I think there's like 2 days that I haven't counted because I wasn't doing any coding. And then there were several days where I was doing like terrain stuff that I wasn't counting because I just wasn't thinking about it. All right. This may also, I mean, it should. At least make the angle calculations even better, because then at small angles, I'm not running into floating point precision errors. Because radians are kind of a very large... They don't have a large range, I guess. Like the smallest value of a radian is whatever the factor is. Like 50 times smaller than the smallest degree could represent if we were doing math via degrees. Because there's 360 degrees in a full rotation, and then there's like 6 radians, roughly, in a full rotation. So, actually, if that's it, if it's 360 compared to 6, then it is like... Yeah, it is about 50 times, a little more than 50 times. Less precise, technically. Where I was going, I don't think I actually said it, but I'm compiling with double precision now. I was not compiling with double precision before, and now I am. That's where I was going with that. Don't care about that. That's on a scroll bar. I don't care. I think it's because it's treating the doubles as floats when it runs the absolute value. It's like, oh, you should be using the absolute value f for float, which actually means double in double precision compiling. The only kind of thing that I don't like that this means is I think double precision doesn't play well with resources, at least when you have transforms that are like if I turn 50 degrees and then turn back 50 degrees and single precision, nothing changed. In double precision, it's possible I end up with a basis vector, or I end up with a basis that has two vectors being 1 and then one vector is like 0.9999999, and it's like 10 nines in a row or 12 nines in a row, and it'll just stay like that. I think that's something that happens when you enable double precision. But no, I tried to fix it by doing some of my own things, because what I was noticing is that small, every now and then, you would literally not even open a scene file. You would just open up Godot, hit Control Save, or hit Save, and a scene file that's not even open, the transform moves from like 12 precisely to 11 point, like 10 nines in a row, and then some, yeah. Like, you never even opened the file, never modified it. It just, for some reason, opens it, scans it in, writes it back out, and it's a different value. Right, but linking, I know, takes a long time with production turned on. But now I should be getting, I mean, in theory, it's possible that my angles are still maybe a little wrong. Like if my forward, my current forward is like aligned on the axis of my preferred right, then it projects down to, well, actually no. Well, no, it does. Wait a second. I'm thinking about pitch. What I do is I check my current forward to my preferred forward for the pitch on that right axis. But what it means is that if I'm down 1 degree, and I'm perfectly aligned, I'm down 1 degree, it's going to say 1 degree. But if I'm like over here, it's going to flatten this and normalize it, and then it's going to say, oh, we're actually down 1. So that's actually not correct. Okay, here's what I mean by this. Imagine that this vector is this vector is well aligned. It's perfectly aligned, in fact. And this vector is it's rotated either a little towards us or a little away from us, but it's still a normal vector. If we were to finish rotating it, it would probably... I mean, it would literally just kind of push out to here, is what would happen. It would push out to here, and then this would go there. So the angle between these is actually larger, because what I should do is actually push it out here, and then check this, and now that angle actually shrinks. And here's why I say that, because in the case that this is actually aligned to here, the angle between these on this axis, there's actually some information that I lose by projecting it. I lose the fact that if I were to spin this axis a little bit, or I guess if I were to rotate this normal vector out so that it matched, we'd be out here. This would be the angle. So perhaps what I can do is yeah, because what would happen here is once I normalize it, it projects down here, and now it says we're 90 degrees apart, which is not true. It would be like this. It's also perpendicular, so doing a dot product just on this alone would also give me 0. Could I possibly multiply it by the length of this vector? So if I say the angle is 90 degrees, the length of this vector, I mean, I guess I could probably do like actual stuff here. Like if I were just to move it out along this axis to here, that's what it looked like if it was rotated. It would just literally slide over. What if the length that I slide... No, I don't even know that. Okay. But just what if I took then... Okay, this angle's like about 8 degrees, I guess. So then what if I said... It's like 147. $23 over 147. No, that gets me not an angle there. Huh. Hang on. I mean, oh, you're crazy. So when I took him out, he didn't do anything. He just stood there. And he walked around for a bit. And now I don't understand what he's doing. This is not time to eat. He doesn't need to go out. He's sitting, he's like pawing me. You're okay. You're okay, I promise. You're okay. He doesn't even know either because I tell him he's okay and then he looks around like, alright, well, I guess that's it. Jeez. Alright. That was an idea. I guess it doesn't really work. I mean, I don't know, maybe I get more precise. Like, I don't know if this idea really works like that. I'm reading 8 degrees here. But the thought is that I would take this and move it over. I mean, I guess I should actually measure this then, shouldn't I? Because this is a slightly different value. It's like 21. I don't think it matters though. Yeah. I mean, this is probably better, and it probably works once the angles get close, but I definitely have this problem where it wants to be 90 degrees if one of the angles is closely aligned with the axis that I'm giving it. Okay. Put that here. I'm just going to do some theorizing. Put this here. So essentially I should be set up such that, yeah, these two are actually perfectly aligned. So technically the angle between these two are 0. In fact, no matter where, it is this line, but the thing is, I don't know what this line is. How do I define this line? Because I would say the angle between these two is 0 on this axis. But also, maybe this is a case where I don't want that. Because if I think about yaw and my axis of rotation, I'm looking at the axis of rotation from the top. I mean, I guess in this case I was thinking about pitch, which is... Actually, that's weird. This is the same thing. Okay, so yeah, there's two differences here. There's a difference here. If this was looking top down, I would say, yeah, let's rotate so we face that way. Right, I want this angle. I want the angle between these two vectors, like this, as they're currently shown. If it was pitch, however, which is very, very similar, I would say, no, the angle between these two is the same. It's 0, the angle between these two. So... they're different. Okay. So I think what I probably mean to say then is signed angle 2 is correct for what I actually want it to do on yaw at least. But for pitch, there's probably something different where I actually do want to rotate these so that they lie in the same plane and then check the angle between them. The signed angle between them, which should just be 0. Because for pitch, the first thing I want to do is I'd actually want to essentially line these up. So I don't want to lose any of that information. Well, actually, I don't know, because pitch... Never mind. So pitch is kind of like... I think that's what I do. I think this is just a unique thing for pitch where I do have to keep that information. I don't want to actually lose the information when they're on different planes, or when they're off the plane that I'm comparing. Okay. So I should just have signed angle 2 now. Perfect. I mean, I guess I just run sine angle 2 and see what they say. So this reads 0. Angle still reads 1 because I made them... I made this a bit weird. But this should be 0. Cool. So they agree. Alright. Has desired rotation is true. I don't know why that's true by default. I don't see why that should be the case. Okay. Target forward, current forward, and then signed angle 2. And now I see. All right, well, it's correct there. I do think I have to pre-rotate these I think I need to do that, but I'll see what happens if I don't do that. Oh, I was like, there ain't no way. I think it's still that I have the Y. Whoa. Alright, it just freaked out. Yeah, okay. That was funny. Well, what happened? Where did it first go wrong? Simiko's keeping up well. Okay, so these two values on the side are small. Okay, they've built up quite a bit of error, and now they're... Okay, these are going... Yeah, these are flipping it upside down now. Yeah. Okay. So what happens if I keep turning around it? Oh. Yeah, okay, it gets... Alright. Let me just see if I do that. If that solves my issue. Oh, okay. Yeah, I really don't know. I don't know what's going on with that. It's also weirdly just constantly rotating. Can it act? Is it actually going to correct itself? No, I don't think it can. Yeah, okay. I think it is because once I'm roughly at 90 degrees, it's going wrong because it thinks it does have to do a really high roll, right? Let me just start with looking at these. So print current right. Preferred right. And then I print the rotation that we calculated from that. I think it is because, like I said, once it hits 45 degrees, it thinks it needs to do a huge rotation. Yeah, so it's kind of like once I cross that 90-degree point, it's really going crazy. So my current and my preferred They're actually not too far off right now. Hang on, what? They're actually not very far off. Let me try this. So break once I start trying to change way too much. Okay. So it just had a huge pitch, and what I saw was it actually went up and then it fell down. So, I mean, honestly, here's the real thing. These should be nearly zero all the time. So in fact, because of how I apply the rotation, these should be staying zero all the time. So as soon as this is not zero, I need to look at that. Okay. So our current and our preferred. Wait, actually, should I be rotating backwards? No, I actually do want to rotate these in that direction. Yeah. Let me say this. If not, this should always stay zero. For what I'm doing, this should stay zero. Okay, the thing is, I'm already seeing it print values that are non-zero. As soon as it's not zero. Okay. Is pitch doing something? Maybe pitch is doing something. All right. So that's how quick it happens. It is also the case that my preferred right has gained some rotation, which doesn't make any sense. So that's, I guess, the first problem. Why has my preferred right gained some rotation? What are my ground points? Are all of my ground points the same height? All of my ground points are the same height. So I actually just straight up don't understand how that happened. Well, actually, my preferred right is 0. Okay, so it's just like not displaying enough precision for me, but apparently one of these is not 0.05 somehow. In fact, these both still say zeros. But apparently at this point I decided to do some pitch, and I think it's just because my preferred has dropped slightly. So I attempt to do some pitch at this point to account for that. I mean, I guess I can just say if the rotation is actually just small enough, then I skip it. But I probably shouldn't do that, because if there are small deviations, then I actually would like it to get as close as possible. I think it's not really a problem yet. But it does seem like these small errors build up. And at some point they also just kind of, it totally topples it too. All right, let me take that off and let me run this again. I'm just gonna pay very close attention. As soon as I see it's got a problem, I'm going to it's like it's fine. It gets wobbly as it rotates more, and then eventually it kind of like spirals out of control. Okay, so now it's got a problem. So my current vector is here. Maybe I should really look at pitch. I think pitch is going to be a lot easier for me to understand than roll. Because they both should have the same problem. Oh, okay. It got a problem there. I was gonna say I guess I could hit pause, but I can't actually see in this. Alright, well anyway. This is pretty well aligned with the x-axis. Its forward is really well aligned with the x-axis. I mean, it's pretty obvious, you can see how well aligned it is. So its current forward is pointing down by 0.6, and its preferred forward is pointing a little bit down. Okay, so that's just not correct. Why is the preferred forward pointing so far down? It's definitely just not right. That's actually a really far down point. Is it this? Where... No, because if this was the case where it's like setting it to itself, then these would just match. It would try to like stop itself from rotating, is what it would do. So preferred forward is definitely wrong. All right, let me hit pause. I'll put a breakpoint here, and then I'll hit continue, I guess. Okay, so I don't know what just happened. My character's like starting to flip over on his head. Okay. So pitch, ground points. Okay, so that's probably an issue. I have... What? I mean, this is... I mean, I guess that's not... I mean, that's not totally wrong. But also... I mean, this does mess with the forward. It does want to point down slightly. But I mean, this is kind of like whatever, I think. It was already a problem, though, because it started to put its feet into the ground. It kind of was already a problem. But I'm trying to look, like, what's actually going on here? Why are some of these ground points really not correct? All right, I think that's not a problem. I think it's honestly just not a problem. Yeah, it's probably because it's reading the target global rest, and it's already bad because it's already applied some rotation and pitch, so it's read in like a rest. I mean, I guess this means it was probably read in a rest value when it wasn't supposed to use a rest value, which is actually totally the case because it's not supposed to use target global rest unless wait, okay, the last leg has a problem. Okay, so next step target is 0.46. Like why? Why does this one have a negative collision? It's trying to like step underneath the ground? What? That doesn't make any sense to me. Why is it doing that? So this means shapecast collided, and that's where it wants to put it, is there. Why? Negative 0.8. This is the front right leg, which is actually on screen right now, technically. It's right there. That's the front right leg. Behind. So... the raycast is just wrong? Also, I'm looking at the sphere. Oh, wait, no, I know what's going on. It's... Okay, that's... Okay, no. That's still not really the problem. That's a bad calculation, but it shouldn't be freaking out already. It shouldn't even be in the position where it's using a predicted position of being under the ground. It shouldn't even be in that location. It shouldn't have been so rotated out of whack that it's predicting a collision point under the ground, is what that means. Because that rest area, essentially I take that target point and I clamp it back to the rest area. So I just draw a vector and then I normalize it and then I put it, or whatever, I just put it in there. Oh, well, yeah, I just take that vector, I normalize it, and then I multiply it by the size of the rest area so that it will stay inside the rest area. Because we shouldn't be trying to place feet outside of the rest area. That's why it's like that. But it shouldn't even have gotten into such a crazy orientation that its rest area has passed under the ground. And even if that did happen, it should be able to recover from that without any issue. All right, here's a test. I can just do that. And see what we start with. Okay, we hit a breakpoint instantly. So my preferred forward is down, which is whatever. My preferred right, that looks exactly correct. It just hasn't scanned for a collision update yet. Or I mean, it should have actually. Hitch, yaw, and roll. Oh, wait. Did I? No, I just want to see what happens. Okay. Let me try stopping that sooner. Interesting. Yeah, like, why is it tilting? Right, this is kind of... Let's give you a small tilt. And, alright, cool. So it instantly wants to do some rotations. What is this? This is pitch? Yeah, current forward, preferred forward. Preferred goes more into the ground and it wants to rotate down. Sure. Preferred goes even further into the ground and it wants to rotate down more. Okay. That doesn't really make any sense to me, but alright. Preferred just wants to keep going more and more into the ground. Is that the problem? Why is preferred forward down so much? That doesn't seem right. Preferred forward should be setting to 0? All right, maybe this is a leg problem. Okay, no, it's still not a leg problem, but it is like, oh man. It is a body being dumb problem. Or rotation being dumb problem. What if I turn you slightly? What do you think about that? Why don't you look at me? What? Now I'm really confused. Why does it not look at me? What the hell is going on? This is so strange. What? What's happening? Huh? Wait, what? This is strange. Maybe it is a problem with legs or something. What? Target. Global position. I am super duper confused. Super confused about what's going on here. Oh man, what is this? All right, let me do this. Oh no, it's body basis. What is happening? Transform zeros, right? And it spun too fast. What? But this is zero, this is a nothing basis. This is a nothing basis. This has no rotation. How am I supposed to... What? Okay, how about this? Crawler. If my basis is not when I ready, huh? All right, if my basis is not 0, I set my transform basis to be that. How do I check if it's like... What is this? Oh, and it just spun out. Okay. Interesting. So if it actually has no reason to rotate, it spins out and does that. Good to know. All right. Anyway, I need that because if I do this, the body should not flip out. It's going to flip out anyway, but... All right. Whatever. Or rather, what I meant to say is if I do this, a 5-degree turn, it's not... It's broken. Okay. It's instantly broken. What is that? What is that? This doesn't make any sense to me. What is going on? I just copy the basis to that one, and then I clear mine. It didn't clear the basis. Why does it not clear the basis? Right at this point, what is my basis? It's clear. All right. So I'm going to hit continue. We hit it again. Like, what do I have to do to make that work? And then it just stays looping like this forever because it never actually updates it for some reason. Why not? Why do you never update? Why do you just quietly pretend like everything is okay when it's obviously not updating the basis? Relay breakpoint there. There's my basis. I continue. It's still the same value. So it's ignoring what I'm doing, and I don't even understand why it's ignoring it. I don't have anything setting it back. And then even after this line, it says it's normal. It says it's correct. This is stupid. This is stupid. What the hell is different? What is different? Nothing's changed. 0.1. Huh? Wait. Okay, so these are the same. That's cool. All right. Good to know. Now, what is going on? What's going on? Why did I need that? Because I was noticing when I started with a different rotation, it can't figure out what to do. It's wrong. This is wrong. This is wrong. Because the basis is wrong. That's what the problem is. When I start this with a rotation, it doesn't understand like what is that? What is that orientation? That's not where they're supposed to be. Okay, I see it. It's weird. It's rotating it once. No, it's just applying the same rotation to itself. Which is strange. It's already rotated. So this is the transform of state. So I'm saying 0.86 and 0.5 is what I'm saying. Yeah, 0.86 and 0.5. This is just weird. Why is it doing this? It's literally rotating it twice. Which I don't understand how it's doing that. Because when I did 45 degrees, it looked like it was 90 degrees. Then I did 60 degrees, and now it looks like it's like a flip over the axis. Which is what 120 degrees kind of looks like. Or yeah, flip over like the... If you take the axis of the 90 degrees and then you take a point at 60 degrees and flip it over, it becomes 120 degrees. So it's rotating it twice. So it's getting a target global arrest at a weird location. But that doesn't make sense. I don't know how it's rotating this twice. And it's just so odd. Like, why is it over there? Because it gets the offset between this and... I mean, it basically just gets its offset. Between its global point and that. Is it because no, this is the green circle on the ground. This is the green circle on the ground. It's globally painting at that point. It's as if target rest position is already rotated. Like, what does that say? What's target rest position? Okay. Let me put on a marker and see where that point is. This is the first leg. So does this leg. So I'm going to see where it wants to put this. Yeah, it wants to put it over there. That's just not right. That's not taking that target global rest. Target global position. So it starts with target rest position. Oh, is that why? Okay. Yeah, I need to like just straight up invert this. And now where you want to put it. That looks better. I was gonna say, can I just copy this? Okay. All right. That was definitely a bug I needed to fix. Definitely a weird bug I needed to fix. All right, cool. And he looks back at me. Okay. So in theory, can I now take you and hit you down a little bit, and maybe you recover from that. Oh. He did, but only after I had to move. What if I pitch you down more? Yeah, like a lot. Yeah, it can still hit the ground. Yeah, it still hits the ground. Oh. Oh. And I think he's just spun out permanently. Maybe not. Wow. Okay. Oh, well, the angles are still definitely crazy. Can he handle 10 degrees? I mean, kind of. It's a bit weird where it doesn't want to fix its rotation for some reason. Not sure why. It like waits until it takes a step and then it tries to fix it. It's a bit weird. Okay, but that's definitely a better... That's what it should be. Okay. I don't want to go another day. I really don't want to do another day with this, but I don't have it yet. All right, let me try this. No, it's still like really, yeah, okay. It's even worse. Yeah, that's even worse. All right, what if I did this? It seems like if it gets any rotation, it's still gonna wobble out of control. It's wobbling right now. I could see it. Yeah, so it's just all wrong. Something about this is just totally wrong. But I mean, it looks like from what it's doing the right... It's doing this correctly. It did look like it was getting the right angles from what I saw. I know there's a problem where if we're at 90 degrees... Well, I guess it's only if preferred forward. If both of these are like really different from... Which preferred forward is just calculated as its ground points, which happen to always be in line with the current forward. Yeah, I mean, it does... I don't know, it's weird. It starts to wobble. Current forward on that right axis. Preferred forward. You know what, let me just try some crazy stuff. Let me just see if I make pitch negative. Yeah, okay, so that's just definitely not pitch being negative, but roll being negative. Nope. So I mean, I'm like correct as long as it doesn't, it's not too much. Also, the fact that like these points are like hitting in the air is like annoying. I don't really know why that's happening. Yeah, okay, I don't know how I did that, but I just instantly tripped them up by going this way. Yeah, like what's that? What's that? What's up with that? It could be that these are just wrong. I mean, alright, here's one thing that I know. Technically, I should be able to turn all of these off, and I get the same result. He's not. That thing is staying at like 0 all the time and then sometimes doing something different. Why don't you fix your legs though? You should really fix your legs. Why aren't you fixing your legs? Oh, I guess has desired rotation should only be true if this is like... Well... Yeah, I mean, it should only be like... I don't know, what's... Why was it doing it before? Wait, how is it doing it before? Oh, it's because it was checking if these were already very well aligned, and then it was saying... Oh no, it's not doing that at all. Okay, but has desired rotation should be true if... Yeah, if it's trying to do this. 8.7 E minus 3. If I want to change by more than half a degree, then I say that's true. Wait, is it because... Oh. Maybe I understand. Maybe I understand. Maybe it's because it's... I should be making this out of... Yeah, like current right, current up, current forward. And I'll leave a note here. Note the z-axis is flipped in... is flipped here. Yes, current is flipped. Is that what the problem has been? I think that's been the problem. Because now he won't do it. Maybe that's not a problem because I have 1,000 errors. What is going on? Must be normalized in order to be cast to a quaternion. Are you serious? What are you talking about? Basis must be normalized. You really think this is not normalized? Use get rotation quaternion. Oh. Oh, where are you going? Alrighty. So this is just junk? Is that what I'm getting here? This is just junk? This is garbage. Wait, is it doing this multiplication first? Okay, no. Hang on, is it actually just junk? Or what? I don't understand. Why would this be... Goodbye. Okay. What? Why? No. This part shouldn't be wrong. Why is that wrong? Orientation, get Euler angles. We do... I create a quaternion off the difference. I do quaternion of my orientation. Multiply that. Multiply orientation invert, which is inverse. This is the same thing that I do here. What? Why does that not work at all for me? Why does just doing this, which in my mind was just to get a more accurate value out of it? Why does that not work? Because if I literally just comment all these lines out, it works. It doesn't seem to be weird. Why is it a problem here? Alright, dude. Look at me. It gets like a little bit broken, but that's... I'll see, whatever. Alright, what happens? Let's turn your speed down though, you're gonna be way too fast. Whoops. Come at me, bro. He's really having a hard time walking. Why are you struggling so much? I'm not sure why he's stepping so strangely. I'm just gonna ignore it for now. I want him to walk over here along this. What do you think about this? What happens when you get on this? Alright, let's go to the big slope. Can you get up this slope? Oh man. I can't believe it. I can't believe it. He's still looking at me too. I made him pitch up to look at me now. I don't have a pitch limit. I will have to make a pitch limit because otherwise he probably... Okay, yeah, he like can't even walk towards me. Come on up here. Okay. His body's hit the ground. What do you think about that? Oh. Okay, no, I think it struggles to climb because it doesn't actually push off the ground, perhaps. And then he's gonna flip over. Okay, and now he's just totally broken. Okay. Huh. So what I wanted to do worked, minus this. So honestly, forget it. Literally forget that. Delete this. Dude, it's working. It's actually working. Pretty much how I wrote it. Pretty much how I wanted to write it. It's working. The walking is broken now. I'm not really sure why how the walking broke, but it's really struggling to walk right now for some reason. What did I thought I kind of made that, but okay, it's really odd in how it moves. All right, let's maybe go to a more regular slope. I don't care. Actually, I don't, whatever that conjugated thing was doing, I don't care that I don't have that. Like I said, in my mind, it's like when you yaw and you tilt, you build up a roll, and you have to correct for the roll. My thought was, okay, well, that Euler doing that quaternion thing is going to give us that roll instantly, so we like should stay at no roll. I don't even care that it's not there. Yeah, so right now it doesn't, the body doesn't push off the ground correctly, so it just kind of slams into the ground. And then, well, I was gonna say if I turn around, it actually, oh. Okay, well, gravity will fix that. Oh man, there's no way it's rotating. I almost don't want to believe it. I actually just don't want to believe that it's rotating correctly. So the other thing is that the main legs, I do need to count all legs. I can't just count the first 4 because it's large enough that its middle legs actually should be affecting its tilt. So, or roll, whichever one. And that should also like, would technically help it climb a surface, a sloping surface better. All right, but I'm sending that and I'm calling it there. I'm calling it a day. That's, I actually just can't believe it. Like I said, I do not care that I don't get whatever possible benefits came from using that quaternion rotation. It was just straight junk. I don't know what's wrong with it. It was actually just junk. I don't understand what the math is doing. From what it looks like, and doing quaternion multiplication is always weird because you have to think about it in reverse. But because it's doing it on a line, it's like this one transformed by this one, then this one transformed by all of that. So it's, I would take the difference, I'd rotate it to my orientation, and I'll take my opposite orientation and rotate it by that. So it's like, I don't understand what it's doing. I literally don't know what it's doing. But yeah, getting rid of that, like I said, should have done, like the only point of that was like a correction to make it rotate better. It's good enough. It's actually good enough. Maybe I could do research at some point in the future to figure out how I can like re-correct for any roll that I would build up from doing a pitch and a yaw at the same time. Because like I said, if I yaw and then pitch, yaw again, and I've built up a roll, right? I've started doing this, so I have to correct for that. I don't know, maybe doing that, maybe it is correcting for it. I don't know. It's obviously, in my case, it's wrong, or I did it wrong. I don't know what it's doing. That's the main thing. I don't actually know what that's doing. like I said, my assumption is that it's a correction to like pre-correct for any roll that I'm building up. So I start rolling. I roll out of a roll that I'm adding. Whatever. All right. It's diff. It works. And I am actually just shocked that it works. It looks at me. It walks to me. Now I just have to make the leg collisions better. Because like I said earlier, and I had to stop myself like 3 times or something where I was like, okay, well the rest position is on the ground, which is not correct because that's not where the collision point is. It is because I clamped that to the rest position, but I have to... What I should be doing is the rest position should be like a huge vertical column. And if I'm anywhere in that vertical column, then I'm okay. So it should only project backwards, really. I have an extra line there that shouldn't be there. I can't believe it. I actually can't believe it. And I get this like rotation overshoot thing. Alright, yeah, I just deleted that whole thing and rewrote it all. Not a single line kept. Except for that, I guess. That's kind of kept. That's just crazy. Oh, and then I need to take that off, too. Otherwise, it's always following the player. Which, I don't know, maybe that's okay for now. Well, not really. I'm just going to take it out. So yeah, I have to inverse the target global transform. I'm not sending that. Fixed rest position's not rotating with the body. That one's actually been fixed. So I can just cut that. And then I want to fix leg rotations over time because after it moves enough, it will... The rotations just look odd. Like a joint that should be kind of like flat eventually starts pointing really far down when it should not do that. And I think really all I have to do is that every single process frame, I just move the rest position slowly back. If I'm not stepping or something. Like I'm not moving and I'm grounded. I'll have to figure that out. I'll have to figure out when that happens. But this is good. And in fact, I'm also gonna scratch this entire line here. I'm also supposed to multiply. Oh, that's for later. Okay, but anyway, this entire thing is scratch. That whole thing is scratch. Don't do that step. Wow. Redo crawler orientation. Angular rotations. I think I tested it thoroughly enough. I was jumping up and down. I made it look at me. I started flipping. I started in the ground. It fixed itself. Maybe there's a little bit of wobble here and there, but I think that's probably just because the rest positions were like, oh, when are we going to be like this? No, now I'm going to be like this. So that's why it was kind of wobbling pretty hard. It works, I think. And I hope. Prowler now turns to face the direction it moves in. And will pitch roll the body to account for leg positions. I mean, I can't get too excited, honestly. Like I want to get really excited, but I should not be, because it's possible there's a serious problem with it that I might discover. You know what? Let me ease my let me try to ease my conscience a little bit by making it have some crazy starting rotation. Look at me. It is like, it's doing it. It's doing it. Look at me. It fixes itself so fast. It doesn't spin out of control. It doesn't flip upside down. The walking is broken right now. It's definitely just weird. I'm not sure. I don't know what, maybe it's just the max speed is too small and it kind of steps over itself too much. Whoa, okay. I think it is just the legs are being weird. Go over there. Go up there. Like I said, I'm not gonna get too excited because I don't want to. Okay, don't touch the ground though, because if it starts up. Okay, come over here. Yeah, if it starts flying off into the sky, then it's over for it. It can't. It doesn't fall back to the ground. All right, I just want to see what happens. I know it's definitely not gonna. Yeah, I mean it's not gonna react to this at all. But that's the next step. Once I get like actual ground collision, it'll be able to step up on this, and it will like it'll get dragged along and turn around and things like that. And if I put it in the middle, it would it'll spin, but it'll keep rotating backwards to fix its rotation, so it'll like try to stand here, like facing that way forever. Oh man. Alright, I just want to see what happens. Can you come over here? Oh. How about you come over here? Stand right in front of this thing when it hits you. I mean, it's just gonna get launched. It's not. It's just gonna launch and it's not gonna fall back down. Yeah. Okay. There it goes. Wait. What? Oh, is that error? Wait. What? Why did it stop itself? I don't understand. What do you think about coming over here? Okay. No. It does. It's totally broken. Can't believe you're spending days make a spider thing work. I can't believe it either, but it works right now. I mean, the stepping is wrong, but I can fix that. The rotation was the part that I needed to make work. Look at me. Look at me. Like, it looks at me and it walks to me. That, like, I do not like how difficult that was to make happen, but now it's happening. Yeah, I mean, it just totally breaks apart when... because of how it's clamping the target position to the rest position, it's not allowing it to come up to the surface. It keeps it inside of like a sphere as big as that green circle. Truly fit. Yeah. It works now. That's a big win. It did take me, I think, probably 4 days to figure that one out. What day am I on? 8. It probably 4 of those days were just making it rotate, honestly. I just hope that actually is it. I just hope that's actually it, and I don't have to come back to this and redo it over again. This should be good. It should be extendable. I can just tell it, you know, for the pitch, I can have it clamp or whatever. I can make it pitch up and down a little bit to look. I would have made it one day. If you can do that, if you can make what I've done in one day, that'd be awesome. I don't know what I'll say about that. I just hope that stays working. I'm worried. I don't want to. I mean, I just gotta wrap it up. I gotta send it, and I gotta go. All right. I should put need a spider enemy for my game. I can say this has been such a hard problem. More difficult because I'm integrating with a physics simulation, which means I have to use angular rotations or angular velocities. If I could just do rotations, I would have been done in a day. But I'm using angular velocity, which means it's part of the physics simulation. Which means if a spider is sitting on the ground spinning at 100 miles an hour and I touch it, it will launch me. That's the biggest thing. I can physically apply impulses to, like, if a bullet hits the spider, it can be physically, I can just say, oh, apply an impulse right there, and the spider will just go blah, you know? It'll do it. I don't have to do any coding for that. I just say, yeah, apply an impulse here, and it's... Oh, jeez. Okay. What about this, though? Let me do git commit, and let me say that, and then git add. Let me check. Yeah, let's go. Alright, now I just pray that my computer and GitHub does not explode. And I guess Twitch too, because then even if all that happened, I could go back to my VODs and just look at all the code I wrote, be like, there we go, copy that. So hopefully, and YouTube doesn't, I mean, yeah. I'm always worried about losing stuff. I've never lost anything, but I'm like so aware that it can happen. All right, anyway, that's it for today. Thanks for watching. I'll be back tomorrow with no more of that. I am moving on. This is just like I could move this to be later. Honestly, I can do this anytime. But I feel like it's also going to be such an easy thing to do that it will just be a quick, like, 1 hour or less. And then, you know, optimistic dev time, I probably have to multiply that by 4, so it'd be 4 hours. Whatever. And then I'm on to gravity forces, and at that point, it should be climbing anything upside down. Which, I mean, yeah, it'll be weird because it has to pull itself into the ground, and it has to be pulled away from the ground. Yeah, I mean, I guess if I think about it like that, it needs to pull itself into the ground with some force, and then cancel that force when it's too close to the ground. I mean, it'll just basically be like a spring. It'll take all of its legs. It wants to be, you know, whatever offset from its contact point of the legs from the ground. I mean, honestly, I could just put like a regular spring on the center of its body. So if it's going over really rugged terrain where there's like something in front of it, it could, you know, push up or something. Or I don't know, maybe not. Whatever. I'll get there. New problems. New problems. Alright, that's it for today. Thanks for watching. I'll be back tomorrow. Goodbye.